Try that all out. All right. Okay. Cool. That is all working. Okay, let's see if this is all working. All right, testing my volume. Yeah, I think that's all good. Yeah. I think that's all good. Cool. So, now we put that to the side. Alrighty. Cool. That's all working. What else do I need? Actually, I want to see how much interference that runs. Let's have a look at that. Let's see if my fan is audible when I run it. Let's have a look at that. Seems okay. Alright, I think we're gonna go and try this. Oh, it went live right away. Oops, sorry everybody. I did not realize you guys were watching while I was already recording. Very sorry about that. Normally YouTube doesn't go live right away until I press a go live button. So they changed that in the interface. So yeah, you have been watching me experiment for the last 3 minutes, making sure everything is working. So welcome everybody. Again, sorry for that start. I was not realizing that we were already recording. Let me just adjust my camera a little bit because it was chopping my head off. That's not good. There we go. Alrighty. So welcome. It is a little bit of a hot day here in Sydney, so I have a fan running. I was just checking whether that was noticeable on the mic. I don't think it is because it's not directed towards the mic. But if by any chance the fan does start interfering with the sound, please let me know and I'll turn it back off. But I'd like to keep it running because I am going to be in a sauna if I don't. So good. Welcome to a little ad hoc stream. This is an unscheduled one. I kind of alluded to it in my Friday live streams that I did want to do a few of these from time to time. obviously, my main feature on my YouTube channel is the tutorials that I do, and that does take quite a bit of preparation very often in looking at, trying out different techniques and figuring out how to do certain things and then present them in a tutorial. And I figured it might be a nice idea, as an experiment, as something to try, is do some of that experimentation, some of that research while I'm actually recording a stream, so that people can look, watch along, maybe give some tips and some ideas, bounce some ideas back and forth, but also to give you guys a little bit of an insight on some of the process of figuring out how to approach certain things. So generally, that's my way of working with these things. Is I just do a bunch of experimentation, a bunch of trying out ideas that I have, and then I'll make a tutorial based on that idea and see if I can make it work. That is not to say that that is the only way to approach a problem. There are many ways to approach a problem. And I might not even get the best of them from time to time. I do try to look at what other people do, but especially the sort of thing that I am looking at today, which is continuing with the object interaction project. I found it very hard to find good info on the internet about these sort of things and how you approach them and how you do them. So I'm just going to go down a certain path that I think works, or presumably works. That's what we're going to try and find out today. And who knows? It might be might be a good idea. It might be a bad idea. We'll see. Okay, so when we look at this, what you see right now, this is part of my object interaction tutorial series. So there's already 2 parts in which I'm building I built the little dart game. I'll demonstrate that in a minute, just for people who are catching up. The building itself, the environment itself, I didn't stream, I think. Did I do an ad hoc stream for that? I can't remember. I don't think I recorded that. I think I did that just in a weekend at some point preparing this tutorial series. That said, I don't mind having a quick go through how this is put together, because it is it is a nice way to organize something like this. Quite simply put, hey Game Endeavor, how you going? Quite simply put, if you've ever played Sims, you would have a really good idea about how this came to be. Basically, what I've done in creating this building is create a bunch of standard objects that we then reuse. So when you look at the walls, for instance, I actually need to go into the living room. So each room is its own scene. So when you look at the main scene here, you see that we have the hallway, living room, bedroom 2. So those are all those different rooms that you see over here. Every room is its own little scene that just makes it a little bit more manageable. And then when you look at the building here, you can see, or the room here, you can see that it's built up out of reusing a single object multiple times. So I've defined this wall segment here, which is a very simple mesh, just a standard cube mesh set to some fixed dimensions. So it's 1 meter wide, it's 2.5 meters high, it's offset by 5 centimeters. No, its thickness is 5 centimeters. And I think I offset it as a result as well. Yeah, I've offset it then half of that, so 2.5 centimeters. The same with the Y, I offset that by 1.25 meters, so that the mesh is actually aligned with the bottom of the floor, so I can stack it on top of the floor. And then basically that mesh is repeated, all over. And then obviously this is just a rotated version of that mesh. So I'm using that same object, that same subscene wall, but I just rotated it, which is possible because it is, if I zoom in a little bit, it is actually on that center point. And in building this, all that I do is I set a snap on, and I make sure that my snap is on 1 meter. So as I move my walls around, they move exactly 1 unit sideways, and that way, you can simply grab a wall and you can say, well, let's duplicate that wall, and then I do need to turn snap on. So let's undo that. Say use snap. And now you can just move it there, and I can duplicate it, and I can move it there, and now I have some more wall sections. So that is basically how this is built. The same with the floor. The floor comes in a 2x2 and a 1x1 meter segment, and that's just to make it easier to create a bunch of them. Because if I need to do all those little 1x1 tiles, you're busy forever. So I've made a few bigger ones for that. Same way, I actually have a ceiling, which you cannot see because I hide that one at the start. So when you see the ceiling, you see that every room has a ceiling as well. That is important for when we are playing the game. So that's hidden by default, and I just unhide that in my ready script to run. There's a couple of other things. So there's a separate one for the door spacing where where we have a hole that we can go through, and that's sized in a way that the door objects that I have nicely fit in there. So it's all just about creating some simple objects. The other thing which is really important is that these walls don't actually have a texture. If you look at this wall, it's a beautiful gray wall. There we go. But instead, there is a little script on this that allows me to set a material, and it will apply that material to the wall. And that's actually a tool script. So that runs in the editor, and that allows me, when I'm using those walls in my scene, is that I can set up a material there, and I can make sure that the wall is properly textured. And that is important because different rooms, like for instance the bedroom here, has a different texture. I've got a green wallpaper there. For my bathroom, I've got a nice little marble texture there. So yeah, the same with the floor. So they all use the same meshes, but I've got a different texture that I use for the kitchen as for the ground. So I've just got these standard objects, just a handful of them, and I just use them to quickly put a scene together. The window is just an object. Of course, need to go back in here. So there's a window here and there's a window there, and again, that's just a scene. All that it is. And this one's actually not properly positioned, which is a little dumb of me. But I'm not going to reposition it because I'll screw up some of the other objects. But that should have been positioned nicely on the center, so I need to clean that up at some point in time. So yeah, that is all the how I build the building itself. Then inside of the building, all the meshes that you see, like the bench here and the kitchen things, that's all from Kenny. So. That was the wrong button. Kenny.nl. There we go. Yeah, it is a Sims house in every way possible. You could create a Sims game like that in this manner in Godot quite easily. And obviously, you need to have a little bit more control over it. But anyway, where is the Kenny thing that I use? Which one am I? I think it's a furniture kit. So yeah, so I basically downloaded Kenny.nl's furniture kit, which has all these cool objects and stuff. And what you'll see is that some of these I've used the obj file. So if we look at assets, there should be a Kenny.nl folder in here in which I use a nature kit just for the outside, so I dressed up the outside a little bit with some trees and fences and stuff, just so that if you look outside the window, you actually see something. There's a little simple height map based ground there. That's just to create, just to create some. I think I actually use a noise function for that one. Just as because the whole thing is inside of the house. We actually don't leave the house in this thing, but at least it gives you something to watch out. We also have a little HDRI. I've got this thing as a night scene because of some of the lighting things that I wanted to experiment with inside, including finding some of the bugs in some of the lighting things that we work with. So that's actually something that I want to spend some more time on. But everything is lit with lights inside. Very basic stuff. I haven't really done anything here to optimize it for VR in any way, shape, or form. It runs nicely enough on my lower end laptop, but Yeah, this is a higher end laptop which has absolutely no problems doing something like this. But there's so much room for optimization in here. You know, one of the things that you can do, which is akin to what I did in one of my other tutorials, is making sure that whatever room you're in, we're hiding all the rooms that you can't see. That's also one of the reasons why I put everything in separate scenes. I haven't put that logic in here, but it would be really easy to add in and make sure that the bedrooms are hidden. And that's the thing. The other thing that I did just for fun is I used my little mirror trick here. So that you can look in this mirror and you see the room reflected, but it's actually just a mirrored room. I do use two viewport textures here with cameras to render the hallway. That's why when you look at it from this angle, it looks weird. It only works when you're actually properly inside here. Again, with the ceiling missing, it doesn't look right. But those are fun things to start playing around. So you see the camera that is used to get the view in that window. Again, you only see a small bit in that mirror, so it doesn't have to be perfect. It just has to be enough to hold the illusion. But yeah, I'm planning to use that to do some fun things with inverse kinematics at some point in time, and making sure that we can actually see ourselves in the mirror as a character, which will be cool as a startup sort of thing where you want to design your own character or something like that. Who knows? We might get there at some point. Anyway, back to Kenny.nl's setup. I actually used to have the OBJ files in here. I guess I removed them all because I started off with the OBJ files and then I moved over to using the GLTF ones. And I did that because the OBJ files, when you get Kenny's assets, they are a single mesh. And that means that we can't actually interact with them. So I've been moving them over to using the GLTF files because in that case, let's just do new inherited and go. Oh, that's a bad example. I need something that actually has multiple parts to it. Let's try that one. A drawer. There we go. So when we look at this, then it's actually exported with a drawer button and a drawer top. So when we grab that one, we can actually... can't I move that? Oh, because I've got snap on. Here we go. We can actually move our drawer. Now, obviously, we don't have any lights in the scene here, so it's a bit hard to see. But that's going to be very important for our object interaction to actually be able to pull those drawers out and have some fun with that. All right, let's have a quick run through with what it does right now, and I'll show you guys some things. Now, I'm going to be doing this seated. This environment is meant to be used standing up, so I'll look like a dwarf. That's nothing bad towards the people who are on the smaller side. Just warning you, it looks a little bit weird sitting down. Maybe at some point in time I'll add something in this environment that you can play this sitting down and that we actually move the character up as a result. We will see. For now I didn't do anything like that yet. I'm also using my my Rift S, not my my index for this project, because I use the Rift S the Rift S SDK for this. Whoa, something's going really messy right now. Alright, let me see what's going on. I've had this problem before with this thing where... Let me try it again. I don't know why, but it messes up in the headset when... And I originally thought that was when I was recording. That is so weird. What is going on here? Does it have something to do with this? No. Okay. Okay, so it goes wrong once I make it full screen. There's something... Hold on. Let me see if I change my settings to just start it full screen. I think there is something wrong when I switch resolution. It looks like it's not calculating all the, or recalculating all the buffers correctly. That's an interesting bug that I need to fix. I originally thought that was my recording software causing that. But obviously it's not. So let's just start this full screen and see if that fixes our problem. Yes, it does. Okay, so that's a good thing to know. There is a bug in my VR driver that if you change resolution, it screws up. All right, so like I said, I am sitting down right now. I've got my little controllers here. With my right controller, I can move around. With my left controller, I can do some of this stuff and move around the building nicely. There you go. So here you can see that we can look outside and at least have something mildly interesting to see. And here we've got the actually need to add a strafe setting to this, I think. But yeah, we can see the mirror working, so that's kind of cool. And again, like I said, that's completely fake. There is no mirror in this thing. It's just our room in room actually mirrored. It's kind of cool. And then the thing that I made last time in our last tutorial, and I need to be careful because my desk is near here, is this little, whoops, that didn't stick in. And that was my, okay, I need to sit back a little bit more. Sorry about that, I just hit my microphone. That was really smart of me. Alright, I don't know how much room I've got to move backwards, but we will see. So that I don't actually hit anything. There we go. And you can see, oh, I missed, I guess. Boom. Yeah, we get some scoring there. But that was the thing that we were concentrating on in our last tutorial series to create that little dark game. It's not counting the outer rings, which is a bit of a shame. I need to fix that up. Anyway, so moving around, some of these objects you can actually pick up and drop, which is using the exact same logic as picking up our darts. So that's just using our object pickable and our grab function. That's the other thing that's really interesting. If I pick up my coffee making machine without the cup, it is no longer part of my scene. Yeah, sorry, the shadows, I haven't set up the shadows really very well. But if I pick up the the coffee making machine, the cup just falls down. That's kind of funny. So that's something that we can look at some point in time. I haven't really spent any time on that. But one of the things that I was working with is actually being able to open these doors. So that's one method that I created. And that's using a similar technique that I did with the weapon tutorial for the two-handed mode. So again, using the object pickable logic. But the other thing that I've been experimenting with is actual using, and this one doesn't work very well yet, as you can see. It doesn't work well at all. But that's one of the ones that I want to look at. But it really scrolls up. But that's actually using, actually applying forces to the door with the controller. And that's the thing that I really want to start looking at and making work properly. So that's going to be our biggest subject of today, is getting something to work with that. That actually reminds me, I also think, sorry, I'm just moving around a little bit. I hope that doesn't make it too busy. Did I also do, no, I didn't do it with the cup. I thought I made the cup work like that as well, but I haven't yet. So that's probably a good one to start with and to start playing around with. How do we make that work? Alrighty. So that's a quick catch up of where we are right now. I hope the audio worked well enough with me. Yeah, microphones are always getting in the way, especially when you're doing VR, because you can't see what's around you. I've been thinking about using a lavalier mic at some point in time, but you can never get the quality anywhere near the quality that you get with a proper mic. So not sure about that one yet, but for VR it does seem to be a better idea. Let me fill that right up. I'm real thirsty today. There we go. Okie doke. So, So when we look at the things that we were just playing around with, so for instance our darts. Now again, I spend a lot of time on the darts in my my tutorial video on that, but that is using the object pickable scene. I think, can I get, yeah, I can get all the way back. So that's one of my XR tools scenes that basically gives us a collision shape that detects when our hand is near. It works in combination with, have I got that all here? So I need to go, yeah, so with our function pickup, which is both on our left and our right hand. So those two work in unison. The function pickup is the hand detecting any pickable objects that are within a certain range of it by using a spherical area. And when it's close enough, basically a button press, which is your grip, which on your controller is obviously, you know, your little side button over here. When that gets pressed, because you're, you know, you're giving, you're making a fist with your hand on your controller, that's what picks that object up, and you can, you know, manipulate it until you let go. Now with the darts, we made all the logic that, you know, when you let go, we measure the speed of the hand, and we give that speed to the object, and the object flies off. Now the problem, quote unquote, with that approach, because that's something that will always be a staple of how we're doing things, but one of the problems that we're having with that is that obviously our hand can, you know, our hand doesn't interact with anything directly. It's all indirectly based on button presses and actions. And then once you pick something up, you pair that thing to your hand. Like for instance, the cup, we pick up the cup gets paired to our hand, and we now move the cup around, but the cup now no longer has any part to play in interacting with the rest of the environment. And that's very unnatural. For some games that makes a lot of sense. For other games, you don't. And you actually want some proper interaction of what you're doing. And one of the games that, in my eyes, does that really well is Half-Life Alyx, which allows you to interact with a lot of things. And basically, they do kind of the same thing, where when you pick something up, it's kind of taken out of the world. But when something's not picked up, you can directly interact with it just by pushing on things or pulling on things. And I haven't played Boneworks yet. I've only seen videos of Boneworks, and Boneworks supposedly takes that even a bit further. And I want to start experimenting here with those sort of techniques and figure out, okay, how can we implement that sort of stuff? Punch out my monitor stream VR. Yeah. That's I need to be careful. I nearly destroyed my laptop because of that. At some point, I knocked stuff over because you can't see, and especially when you're developing, you're sitting behind. You know, your computer. That's also one of the reasons why I'm not standing up right now. When I'm recording my tutorial, I'll actually make proper room for that. So I don't have my green screen behind me. I've got all the room behind me, which means that whenever I actually record doing something in VR, I'll take a few steps back from my desk and make sure I'm not anywhere near my stuff. And I bet you that there are plenty of VR developers who have stories to tell about things that they broke while they were working in stuff, because it's, you know, development is very different from actually playing a game. You know, when you play a game, you tend to make sure you got the space, you're walking there. But when you're developing, you're constantly sitting behind your computer, getting up, doing stuff, which for quickly testing things can become really gnarly. So you try to tend to do things like I'm doing right now, where you stay seated and you still work with it, and then you knock your your microphone over. So yeah, the joys of a VR developer. Okay, so dry throat. Like I said, it's a hot day in Australia right now. Anyway, again, like I said, let me know if there's any problems with the microphone and picking up my fan. I'm hoping it's not very audible, not very annoying. So, when we're looking at our controller, now here you can see those spheres that are part of our pickup. So that's the sphere linked, our collision sphere linked to our area that's detecting whether we're near enough to any object that we can pick up, but it doesn't actually do anything. It's purely detecting what is in range, nothing more. It's not pushing, pulling, not doing anything. So we want to do something more with that. And when we're looking at what's a good example? Do I have any? I need props. So when I've got my controller and I'm moving it around, obviously if I've got an object here and I'm missing an object, like I said, I really need props. I have an object. So when I move my hand towards it, this object is a rigid body, physics body. I would want to be able to push that away. Obviously if I'm near enough and this is a pickable object and I press my button, I snap to it and I interact with it. But if I'm not doing that, if it's just resting in place on the table like the coffee cup, I actually want to be able to interact with it by pushing at it or doing something like that. Now the easy solution is to just add a kinematic body or static body or something to our controller. And as my controller moves, the position of the physics object moves because it's childed to it. And then obviously you would expect that to push my object around. But there's a really big problem with doing it that way. And the problem is that when I move my hand between one frame where it's here and the next frame where it's over there, I'm moving my physics body from here directly to here. So if I'm moving it and I'm expecting to push it away, what I'm actually doing is this stays there and my hand is now there and my hand's collision body is now inside of the collision body of my controller or my cup or whatever object it is. And the physics engine has no idea of what happens. It just suddenly sees from one moment my physics object is here and not interacting with anything, and all of a sudden my physics object is here, it's inside of here. It has no idea that it's being pushed, that it's moved. So it's going to panic and it's going to say, this one should not be inside of that one. I'm going to give a really big force and that flies off. And that flies off, if you're not careful, that flies off a lot. So that is not the way to do that. Now, the solution that I've been playing around with is I've created this node called follow. And as you can see, it's a child of my left hand here. I've also got it on my right hand, so it's the same object. And so I've childed it to my controller. But inside, you can see this is just a spatial node, so it's not actually doing anything. And then we have, my good friend node here. And node not being a 3D object, not having spatial information, disjoins everything that follows from my node. So while my follow node nicely is paired to my controller and therefore moves along as my controller moves, my kinematic body that I have here does not. It stays wherever it is. It is not linked to anything. It has only got a global position as a result, because it's not getting a position from its parent, because its parent is not a 3D spatial object. I am glad that the fan is behaving. I do have it pointing away from the mic, and this is a condenser mic, so it's not supposed to be picking up any sounds coming from the sides. Hopefully. It's not the most expensive one. It's actually quite a cheap one. So surprised how well it's served me over the last year, because I've had it for over a year now. So yeah, thank you Newer for building very cheap and obviously mics that do last. I'm pretty sure that if I would have a I don't know, Blue Yeti or something here, the audio quality difference would be noticeable. But my voice isn't the best anyway, so yeah, I'm sure that you guys can deal with that. Anyway, back to this. So what we've got here is a kinematic body that does not automatically follow or gets placed where my controller is. So in this case, again, the example, I have my object here, I've got my controller here, I've placed my kinematic body where my controller is, where my controller is. That's not handy that I'm using another controller as a prop. So I'm now moving my controller in such a way that it's now inside of this guy. But my kinematic body doesn't follow automatically. I need to do that in code. And that allows me to use move and slide to move my kinematic body. And now the physics engine is properly going to detect that, hey, I've got a movement here. I am hitting this guy over here. How do I now react to that? And it's the same as, a character controller. So in code, what you can see here is in my ready, I make sure that my follow body gets positioned, and I'm actually going to zoom this in, gets positioned where my my controller is. And then in my physics process, what I'm doing is I'm checking how much I need to move. So I'm comparing my new position of my controller with where I was before, because remember, our kinematic body stays where it was. I'm also checking how much I've moved. And the reason I'm doing that is if you do scene switching or if you teleport, if I'm here and I teleport over there, I don't care what's in between. But if I would now use move and slide to move my kinematic body from here and I hit a wall, I might teleport into the next room and my hand will stay in the other room. So I'm checking for if my movement in a single frame is too much. I'm assuming that I'm either teleporting or scene switching or something like that, and I just change my position. I'm not doing my move and slide. If I haven't moved, which is very unlikely in VR, because you move even by just the jitter of your hand. Like I said, I'm duly impressed with the quality of my newer mic. I don't know how. Because this is a $30 mic, and I think I spent $30 on this, and it came with the boom. So it's cheap Chinese stuff. So I don't know how how one is from the other. I might have just gotten lucky with one that's in good nick. But yeah, for a starting YouTube channel, if you don't want to spend $150, $200 on a really good quality mic, I recommend these things. They for what they cost, they're a brilliant startup mic. And like I said, I've been using it for a year, and I'm pretty happy with it. So yeah. Unlike some of the other products that I've heard and read about, where it's hit and miss. I've got a few cheap things here that have really worked well, and I've got a few expensive things here that I'm really happy that I paid the money for. So, go figure. So yeah. So if we do move, and we have not moved more than our maximum distance, then we're going to actually execute our logic. I am copying the orientation, which in this case matters absolutely nothing because we are using a sphere as a collision shape. Can I see that actually? I'm not sure. Because of course it's not centered on this thing. There we go. Is there a sphere mesh? I don't know why it's not showing my gizmo for my sphere. Oh, because it's very, very, very small. In VR terms, this is still a radius of 4 centimeters. So yeah, probably on the center of my hand. Again, this is right now a bowl shape and might not be the most realistic for, mimicking a hand, but I found that this works really well. But in case I decide to change it into either a what do you call it? I lost the word. A cube, or maybe even a proper hand shape. Although I'm very much against using polygon-based collision shapes for these sort of things. It feels like a waste of performance. Much rather use primitives, and again, the sphere is the best one to use. So if it gives a good simulation, use a sphere. So I am copying the orientation, which for a sphere would do absolutely nothing, because it's a sphere. So, but if I ever decide to use a different collision shape, that does, that is important. That is less important that it actually moves that, in interpolation or things like that. Maybe at some point I do need to look at that, because I can imagine that if you want to sort of like tweak something, or use your rotation of your hand to sort of move something along, that might become important. That actually becomes part of the movement simulation as well. But for now, I'm ignoring that. But what I am doing right now is I'm doing a move and collide to move my hand. And at this point in time, I think, if I remember correctly, let's have a look. So kinematic body. Here we go. Move and collide. Yeah, I've got the inertia set to false, and I think that means that when you move, it will stop when it hits the object, instead of actually affecting the object. And that is something that's one of the things that I was experimenting with, and that we're going to be trialing some more in this video. Because not doing that and actually letting the physics engine handle the movement makes a lot of sense when it comes to pushing something along. But I was having problems with that when I was interacting with the door and things like that. And like I said, we might undo that, because I'm not happy with the next little bit of code that I did. That's definitely not working the way that it should, because what I'm doing over here is I'm taking the amount of space that I've moved and I'm using that as a impulse vector. And first of all, I think it's wrong, because it's actually the distance that you move into the object that should determine how much. So if I've moved from here to here, it's only that last little bit that actually pushes the object. It's not the whole movement. So I might actually be applying way too much force to the object that I'm colliding with. The other thing, of course, is that you need more information about the collision to do more, to get more information with that. So I'm not sure about that yet. That's something that I still want to play around with a little more. Notice that I'm only doing it if it's a rigid body, because obviously if I'm hitting something that's a static body, like a table, I obviously don't want the table to move. It's a static body, and it wouldn't even work, because those objects don't have impulse support. Yeah, indeed. It's quite interesting, because I've heard very mixed reactions from people using newer mics. And again, I think it also depends. They have a lot of different mics, and some are better than others. So yeah, but I'm happy with this one. Hey, Hive Time developer, 2 Loft Bees. I love that. I actually played Hive Time a little bit over earlier in the week. I think I finally got it up and running. I haven't had enough time to really play around with it. So I only played it for, well, I meant to play it for like 15 minutes, and then it was 2 hours later, and I went like, maybe time to go to bed. It's a fun game, I gotta tell you. You think a simple concept is how to manage a beehive. It's a really good resource management game. I love it. So yeah, guys, congratulations on what you're doing. It's a lot of fun to play. So yeah, I actually on that subject, one of the things that I'm wondering about, I play a little bit too much Apex, but other than that, I don't really find enough time to play games. I have been playing through Horizon Zero Dawn again, which is probably one of my favorite all-time games. But I have been thinking about maybe streaming some gameplay as well, and maybe looking at some of the Godot build games out there and highlighting those. So if you guys would be interested in seeing me stumble around games that I don't really know how to play, let me know, and I might pick a night once a week or something, or once a month, and we have a game night or something like that, and we just play some Godot games. Might be fun. One of my all-time favorite stories when it comes to game development is the I don't know if it was NoClip who did the interviews and put in line with it, or if it was someone else who did. But the original story about Fallout 1, when Fallout 1 was made, where the guy who they were working on a couple of other games, and can't remember what exactly they were working on. But the guy who got the idea to do Fallout, it started off with him creating a paper version of the game, like a Dungeon and Dragon style version, and doing that sort of in his spare time, and then getting, trialing it with his buddies at work. Like, hey, we can play this game on, because the first one is a turn-based type game, so very possible to do that on paper. And they would end up having very late night sessions doing that. And I think even when I might be mixing up two games, but I think it was the Fallout game that had that follow up where you finally got the green light to build it, but it was still sort of like a side project because they were building this really big game for a publisher. And the story, I think the story went something like that. They would have the QA team when they were finished with testing the game that they were about to release. Can you just can you stay back for half an hour and try this this build of Fallout that we're doing? And they would just play throughout the whole weekend. Some crazy story like that. It was a good story. I think that was Fallout as well. So yeah, if you can find that documentary about how Fallout 1 came to be, it's an inspirational little story. Love it when you just know when that happens, you know that you're on a good concept. You know that you're building something that once you release it, people will enjoy playing. Okay, so. The other thing that I did here, which currently is disabled, but we're going to enable it now, is I've got a mesh here called Visualize. Well, guess what it does? It visualizes the collision shape. So it just draws a transparent ball where a collision shape is, and it will allow us to see what we're doing with our hands. So let's turn it on, and let's have a bit of a play and see how well this works right now and what it does. And we start looking at some of the problems that we're having with it and how we're going to be dealing with those. So here we can see our little balls. They are not big. There we go. Oh, come on, track it. There we go. I wasn't tracking it. And of course, I've got my left hand on my right hand and my right hand on my left hand. That's not going to work. No, I did have them the right way around. I just had them upside down because. Yeah, the meshes that you see on screen are actually the meshes of the original touch controllers, which have the ring on the bottom, and of course I'm using the Rift S, which has the ring at the top. But we have our ball, and you can see that it follows my controller with a slight delay of a frame. So that's also doesn't like it when I hit things. Sorry about that. It's still there. Tracking got wrong there because of the mic getting in the way. Anyway, so yeah, you can see that slight frame delay, and that gives you an idea about how much my controller actually moves in one frame. But because we've got our logic now, if we go and hit our table, which is a static body, you can see that the ball just stays behind. It doesn't actually follow my hand through the table. It actually stays on the table. There's my real table there. That wasn't really good. I don't have any interaction on those. That's actually weird. I was actually expecting that to work because those are rigid bodies. And that might actually have a lot to do with the fact that I'm right now not using that inertia thing. And it's the same. That now does work. That's interesting, because that wasn't working when we tried it before, and it didn't actually enable anything. But here you can see that I am pushing my cup around, because that ball hits the collision shape of the cup, and then by my movement I'm actually using that push. And then because the cup then actually moves against the coffee machine, the coffee machine works as well. So as far as that is concerned, this is kind of working. You can see that if I hit it a bit harder, it actually gets a bit more things. And this is also where the physics engine of Godot, or the bullet physics engine, is a little bit weird. You see how the cup gets back on its feet. Let's have a look at the cup in a minute. That has to do with the center of gravity of the cup not being set very well. And it just deciding to do it. Now the other thing that you'll notice is if I move forward, is at some point I'm still moving, and this sensation probably doesn't translate very well on screen. But I'm actually playing my pushing my player character back. And that is another thing that we that I need to have a look at, whether we can improve on that, because that is the logic. I'm actually using a similar technique as what I'm doing here with the. I really have to be careful not to hit things. I'm using a similar technique as I'm doing here for leaving my shape for my hand, in place when it hits something, for my body. So when I'm moving my character around with my joystick, I'm actually moving a kinematic body forward to test how far I can move, so that if I hit my table, I no longer move any further forward. Now the problem is, because I'm there now, if I move my head forward, I'm pushing that same kinematic body forward, which is actually pushing my body back, which is not really what you want. First of all, it means that if I'm standing up, I can't actually bend over the tabletop. But the other thing is, I'm moving forward and my player body gets moved backwards, and my mind is going like, that ain't right. So it's a little nausea inducing. But it is the thing that prevents me from actually going through the wall, because else I could stick my head through a wall. So that's another thing to fix and actually find a better solution for. That we only check that if we are moving our character with the joystick, but if you're moving physically, that we don't actually detect that we're hitting something. We're assuming that we are bending over something, unless our head actually goes through something. So yeah, that's one of those things that I'm still playing around with and trying to figure out, okay, what's the best way to fix that, to still have collision detection when you're moving with the joystick, but also allow you to bend over things. So lots of stuff to figure out. So yeah, let's have a look at if we can improve this. And I actually want to turn that inertia back on and start playing around some more with that. So the other thing, I love the Rift a lot more when it comes to doing these things, as someone who wears glasses. But it's still annoying when you wear glasses and you take your headset off. With my index, usually my glasses just stay behind in my index. But with my Rift, generally speaking, it goes alright unless I knock them off. So, okay, let's go and make two changes. The first thing is having a look at whether we actually want to use move and collide. Actually, let's click on that so that it goes straight to there. Another, it will slide. That's a slide if it collides. Which information about the collision? If that's true, the body does not move, but it will be collision information is given. Okay, move the body along a vector. If the other, it will slide along the other body rather than stop immediately. If other body is kinematic with a rigid body, it will also affect the motion of the other body. You can use this to make moving or rotating platforms, or make nodes push other nodes. So, and this is the thing that you know, with move and collide, that one is actually decided to just stop when you hit something and then get information back. And I think even if you put inertia to true, I'm not actually sure how much it does, because that's the thing that I don't like about move and slide is it will actually attempt to move completely there and push other objects out of the way, but it doesn't actually give us any information about what it is that we're hitting. So yeah, that is. And the other thing, of course, is that this is a velocity that we move, not actually a distance that we move. So we need to translate our movement to something, which actually means that we probably need to divide it by delta to get our velocity of what we're moving. All right, let's first see if we are to use move and collide. And I'm going to turn this back to true. And now I'm going to comment all this code out. So we're not actually going to do anything with the shape that we collide with. We're going to let Godot handle this. Now I think right now it will mean that we're not moving anything. Because I don't think move and collide actually influences other objects. But let's try that. And if that doesn't work, we're going to experiment some more with move and slide. And see if that wants to do what we need it to do. Here we go. And let's just keep experimenting with our coffee cup. No, that's cool. But what we can see now is that the physics simulation is a lot better than the impulse trick that I was doing before. So I do like that a lot better. And obviously we still have that problem with our center of gravity, so we have to have a look at that as well. But well, I don't know if this translates very well to screen, but the interaction is way better. Whoop. Yeah, knocked it over. Way better when we let the physics engine do the proper logic of interacting with the other objects. So, but I am very surprised with this that it is actually working much better now. If I recall correctly, and we could do that by just outputting some information. If I recall correctly, if we put the inertia to true, move and collide works almost the same as move and slide, and we actually don't get the collider because when we push the cup away, we're actually not colliding with the cup anymore. We've pushed it away. So I don't think we actually get collision information unless we hit a static body or something that we're actually pushing against, and you know, our collision prevents us from moving. Yes, it's not quite sure what you mean with your last message there. 426. Not sure what happened at 426. Okay. Anyway, so I'm going to leave it with move and collide for now. Let's go have a look at a cup and see if you figure out why a cup is behaving so weird. And then we're going to start looking at you know, interacting with doors and stuff like that, and figuring out how we can best make that work. And I'm not going to be using one of the existing examples there. We're going to start with something new because I want to go through the whole process and sort of see, okay, where are we having problems? All right, so that's all good. Where is my cup? Where is my cup? Cup. Coffee cup. Mug. There we go. Boom. Mug. Pretty. Here's my mug. All right. So we can see that our base of our mug is at the bottom. And that is our whole problem, because that means our center of gravity is now at the bottom of our cup. Our whole collision shape is at the top of our cup. That's what makes the cup always go and recenters itself. So I think we need to select it. Actually, let's first figure out how big is our cup. And we're going to check that out with our collision shape. Our cup is 0.55, so 5.5 centimeters. So we need to move this down by 2.75, I guess. Now, that's an average. Can I adjust that here, or is that going to screw everything up? So we would need to take 2.75 out. So let's say that we need to take let's say we move that to 3. Okay, that doesn't work. I was afraid of that. So it doesn't actually really adjust that very well. Okay, so now we're just going to move it down. Oh, and I still got snap on, so let's start snap off. And we're moving it down by 2 points. That's good enough for me. All right, so are we now at the center? Okay, I did something wrong in that calculation, because that definitely doesn't look like we've moved it down enough. Or was I just looking at the wrong numbers? Hold on, let me try that again. No, you would say 2.8 would be there. So where? Ah, because collision shapes are extends. Always forget that. So a collision shape of 0.055 means a total height of 11. So our cup is 11 centimeters. That's a big cup. That's a really big cup. I guess that can be. So yeah, we needed to move it down by 5.5 centimeters. And that means our cup is now nicely centered, which means our center of gravity should be in the middle of our cup. Now note that I am using call it. I'm using a cube for my cup instead of a sphere. I just found that to be a little bit more reliable in this case, especially with the little handle on it. But yeah, we might change it at some point in time and give it a cylinder and then a separate little shape for the handle, just so that it rolls around more naturally. But for now, that is what we do. That does mean that in our living room, our mug is now nicely sunk through this thing. And again, that needs to be turned off. So we're moving it up a little bit, and as the simulation starts, that will fall down, and I will be happy with that. Those empty indented lines drive me nuts. Which indented empty lines? You mean in the script? Like this? I don't know. Never bothered me too much. If that's what you're talking about. Yeah, so basically whatever the well, it's not the origin, it's the location of your physics body. So the position of your physics body is the center, and then however you move your collision shape around it, that affects it. So right now my center of gravity becomes the middle of my cup, because I've centered all my objects on the rigid body's position. So yeah, it's gives some funky issues when you don't get it right, especially with well, like I said, the cup suddenly falls over and stuff like that in a weird way. Actually, let's have a test and see if our cup behaves properly right now, and whether we can knock it over properly, and if it then stays knocked over, or if it will try to re-center itself again, which is still possible. Alright, my boom is in the way again. Let me just move backwards a bit. I'm afraid when I move backwards that I'm going to... yeah, so now we can see that it falls over, but because it's a square, Ah, it didn't like me squeezing it. But because it's a square, it's not nicely rolling around when we knock it over. There we go. Actually, let's play around with sphere shapes. Now, one of the things that I did in here, did I do that in my main? I think I did that in my main. Yeah, I've upped the physics simulation from 90 frames per second to 180. Because with VR, we're working with such small objects. Well, actually, it doesn't really matter whether the objects are small or not. That's the misconception. The problems that we have with our physics simulation is that the acceleration that you get through gravity means that an object would very quickly move much faster or much more in one frame than its own size, with the result that things start to mess up, interestingly enough. All right, so we're going to change this one to a cylinder shape. There we go. And let's go and have a look. Let's actually go and look at it from the top. There we go. Let's go and bring that back down. Bring that back down. Now this now needs to move because that is obviously... There we go. And I actually want to make it slightly bigger so that we're nicely on our points here. So here we can see that our center of gravity is slightly off center of our cup. And I'm wondering, I think that should actually be perfectly centered to make our cup work nicely. So I'm going to move our whole cup a little bit to the left. But we're going to add a second collision shape. Oh, before we do that, let's first go and make our collision shape the right height. To the left view, that's good, because now our cup is way too tall. There we go. Same thing. Let's go do there. And here we can see that we are overextending a little bit, but for that I don't really mind. I'm going to bring my margin back down quite a bit, or else we get into trouble with that. Yeah, I'm not too worried about those indented lines. I actually I got a little bit of OCD kicking in that I want to make sure that I follow through with my indented white space. It's the oops, clicked the wrong thing there. Back to my mug. The one thing that there are people who love it, there are people who hate it, and I'm not sure where I fall. But of course, GDScript being Python based, indentation is everything, and especially with long bits of code. Having that indentation like over here to make it clear that my if statement ends there and does not follow through here, I kind of like that. I kind of like seeing that the indentation follows through. So if I have it like this, that suddenly no longer is tied into the rest of the function in my feeling. So I've got OCD making sure that the indentation makes sense even in white space. But give me C++ any day with curly brackets. I'm definitely on team curly brackets. Don't get me wrong. And in that case, you know, I don't want to see these things at all. You know, they're only there because in Python-based languages, indentation can, you know, if you get your indentation wrong, if I do that, my code breaks. Seriously. So you have to visualize your indentation with things. I know there's people who swear by that and think that's the greatest thing since sliced bread. I'm not one of them. But as a result, I like to see the indentation even on blank lines, just to get a better sense of what's still part of my block. But yeah, I also see that, you know, it's because it's a Python-based language and nothing else. If it was curly brackets, I'd say hide the whole bloody thing. I don't want to see whether there's indentation on my white. Actually, you know, when I look at the rules that I apply in Clang and stuff like that, I think I even remove any tabs and spaces on empty lines automatically. So, but you can only do that in those languages because you use curly brackets to, make it absolutely clear what a block is. Where were we? So we now have that properly done. So now we do need a second collision shape for a handle. And that then becomes a box shape, which of course starts off being way too big. Let's bring that down a bit. Move that over here. Bring it down some more. Or rotate it. Probably something like this. We'll see how accurate we can get it. That's good enough for me. Then we have to bring it in like this. There we go. And now we need to go and set the height properly. Oh, that's annoying. That'll let me do it. This is when you don't have a proper light source, it's really hard to see what we're doing. But there you go. We have two collision shapes, pretty much properly identifying what my cup looks like. All right, let's have a look and see if that actually behaves nice. Well, I'll get used to it, just like I got used to, Python style of coding anyway. It's quite funny actually. I resisted doing anything with Python for a long time after first trying it. I really like Python as a language itself, but the indentation rules, I hated them. I hated them enough that I didn't really want to do anything with Python until I discovered Godot, and I finally had to accept my fate and learn code blocks by indentation, and you get used to it. And if the way that the white lines look, as long as it doesn't break any code, I'm happy. Everything else is just what you get used to, and you get used to things pretty quickly. Okay, so I really want to be careful here because I don't want to knock my cup of water on the ground. Luckily, it's nowhere near my computer this time. All right, there we go. Let's see how well this works now. All right, so now we can see it is rolling. That is working really nice. Well, here we can see our famous physics engine jitter as things kind of bounce back and forward, but at least dropping my cup, because that's usually something that leads to jitter as well with these sort of things. So yeah, that's working pretty good if you ask me. And of course, because it is a circle now, because in real life you would now expect it to sort of rest on one of these faces like that and not move. But of course, it is a circular collision shape right now, so it doesn't really do that. But that's okay. So this is the logic of letting go, that there is some transfer of momentum of our controller in there. I think the other thing is, which you don't really see, is right now the collision shape of our cup is actually inside of our kinematic body. So the moment that we let it go, it actually results in our little ball, immediately giving some what you call it, some force against our cup, because it's inside of our cup when we let go. And I think that's why we see it just immediately move around like that. I'm not quite sure what we can do about that when we have our cup in this way. That's a good one. How do we prevent that? I don't think I've got an answer to that at the moment. Unless we want to, exclude our cup for a little bit while we let it go. That's an interesting one. So we don't have that problem with our coffee machine, because our coffee machine doesn't actually snap to our hand. You can see that we actually pick it up in the position that it was. Well, if we do a cup, it snaps into there. That's one of the features that I did. And for a cup, that makes sense, right? You want the cup to actually be in your hand so that you can drink. It's a really stupid cup with the bottom being all the way up there. But anyway, I think the idea that Kenny had was that you actually texture the top and it looks like the liquid. But then you don't have a bottom of the cup. Anyway, that's what you get for using very simple things. So yeah, it's actually trying to pick it up with that hand. So yeah, all in all, I think that bit works. All right, just want to see if our changes has done anything here. All right, that really still screws up. No, come on. I want you to be open. There we go. Yeah. All right. Let's go and have a look at if we can build something like that. I want to start with something new. I don't want to use stuff that I've already done. We're going to start with a new object and sort of put a new script together and a new setup together. Let's see if we can figure out why it is behaving that way. And we might actually just do something with primitive shapes. I think that's probably a good idea. We're just going to create something with the primitive shapes that we can interact with and can figure out why is it behaving the way that it is. That was my keyboard. Alrighty. But I'm happy with the way the cup behaves right now. And I am happy with actually using inertia, using that logic the way that works. It makes more sense to me. It makes a lot more sense to me. Okay, let's do a little bit more. Oh, it's empty again. Yeah, spring-loaded doors, even though it's not supposed to work like that. Yeah, I'm with you there, Bees. I have gotten used to programming in this style, but I don't think I'll ever like it. You know, I'm a big fan of GD scripts. I still think Python is a really cool language, and there are really cool libraries for it. But yeah, shoot the guy who thought that strict indentation in that way was a good idea for programming. But again, you know, it's in the end, it's personal preference, right? There are people who actually, for all the right reasons for them, love that style of coding, and you know, you can't argue at taste. I guess it's whatever agrees with you. And you know, like I said, I'm on team curly brackets. and even there, you know, if you look at people who like the Microsoft style with the starting curly bracket on a new line, I hate that. Curly bracket for me needs to start on the line that it belongs to, and then you know. Everybody has different ideas, and I guess it's what you grow up with and what you're used to, and what you, as a result, are comfortable with. And I don't think you can say there's a right or wrong with that. It's all personal preference, in my opinion. So I do want to have a quick look at what I did before, just so that we know, you know, where our starting points lie. I did fill this up so that I can actually drink some. So what you'll see is I tried two approaches so far. And I think the right way forward is going to be a combination of the two. Because you interact with a door or anything that you know, even with a drawer where we open or close a drawer. Though I think for opening and closing, for opening a drawer, we want to do what I did with the kitchen sink. But closing the drawer needs to be a push action, right? So I think that's probably the one that we're going to be experimenting with first, and seeing if we can get that to work consistently. That's probably going to be the easier one as well, because it's the hinge of the door that is actually causing the biggest amount of problems. All right. So yeah, so when we're looking at the kitchen sink, I'm actually not using any physics, if I recall correctly. So let's go and see, which one is it? I've got too many of these things. Kitchen sink, that's the one. There we go. There's my kitchen sink. Now, one of the things with this guy is that I did do a full collision shape on the sink, which is really dumb, because you can see how horrible the collision shape on our faucet, what's that called? I don't know how to pronounce that word. Not a native English speaker. But I did do a what do you do it with? Mesh, and then create tri-mesh collision shape on that mesh, because I wanted to get the sink in there so you can actually drop things into the sink. But yeah, it's actually a really horrible collision polygon shape that it creates for this thing. Spending the time to build this up out of a limited number of box collision shapes would definitely improve this thing a lot in many ways. Now, the other thing that I did here, no, I didn't do that here. I did that with the other one. I actually haven't done that here. I didn't know when I did it, because I wrote this a couple of months ago, and I actually didn't know about remote transfers yet. So I actually created my own remote transfer logic, remote transform logic here. So I'm actually adjusting the transform of the door object using this follow thing. So we're gonna change that, I think. And interesting enough, I've got that on an area script here. That's interesting. How did I do that? Okay, so I need to just quickly piece together this. Okay, so I'm actually going to go and take that follow node out. Alright. Pivot. I'm happy to use the pivot for now, but I'm going to take the follow node out, because we're going to change that to be, here we go, set follow, goodbye set follow. And then we're going to take that one out. And we're going to take that one out because I want to change that to be a remote transform. Oh, let's actually make that a child of my follow node first, so that the positioning is correct. There we go. Boom. And now I'm going to go and assign the door to that. Okay, that's interesting. Ah, that's why I did that way. Okay. Okay, that makes sense. All right. Then I think that I'm going to do this the same way that I did with the other one, because I obviously had some logic in there that I'm actually offsetting the door to its original location. No, the reason is that this thing, my kitchen sink, is scaled. I've scaled that up twice because I wanted this thing to be twice as big. Okay, that makes a lot of sense. Well, again, I am going to do this a different way, and I'm going to so we're going to go and delete this guy. Boom. Which now should mean that this guy transform. Let's turn that back the way that it was. There we go. Sweet. Okay. Looks like that was moved in a bit. Okay, let's go and move it back into place. Actually, what I'm just gonna do is don't save. We're just gonna go reopen it. That's a smarter way of undoing the damage that we just did. There we go. It's back. We still should not have our follow mode because that was in a script. That should still be the same way. Pivot. Still have our pivot type. That's good because I was trying to make that work a more standard way, but that's fine. Okay, so we're going to go and get rid of that guy. And instead what I'm going to do is I'm going to add a mesh instance here. There you go. And now I'm going to go and copy this guy. Copy. And I'm going to paste it over here. Boom. So there's our door. And I'm going to hide this guy. So we're still using the same mesh, because remember, when you copy a mesh, you're not making a duplicate of it, you're just copying the resource reference. So the resource still lives as part of our original mesh, but we're now using it here. Now obviously I do need to go and apply our scale here, because we've lost our scale. And interestingly enough, we need to move it in a little bit. That did surprise me. So there we go. Let's move it in a little bit. So now our door is back where it came from. And we now have this pivot point. So the idea is that that pivot point is what the door moves around, like that. Now, one of the problems that we do have, which we can't really see because we don't have a really good way. Well, maybe if we do it like this, we could see it. Because the problem that we still have is that our door has got a collision shape that is definitely wrong, because it collides with our internal structure here, and we actually want it. If we also hide our door here, well, that becomes really, really messy, doesn't it? It's really hard to see, but we should be actually, let's unhide this guy. We are using this plank in the middle of our kitchen to be the back, so that our door isn't supposed to go through that, which right now it does. So let's go and say door mesh. And that means that a collision shape for our door is definitely wrong. Now at this point I've created that as a static body. So again, like I said, I haven't created this door as something that that uses the physics engine to move. What we're doing here is I've created an area that works similar to our two-handed mode of our gun that I implemented in my tutorial. There is where the area allows us to detect whether our hand is closed, and it allows our hand to grab that object. And at that point in time, we can move that around. But instead of us actually grabbing the door and holding the door, we're using that location to adjust the positioning of our door. Yeah, absolutely. When you look at collision shapes, you know, I'm working right now with Kenny's objects, which don't have collision shapes attached with them, so I need to create them myself. But yeah, just doing that properly in Blender or whatever tool you enjoy using most is definitely the way to go. My main problem is when you do that is that all the collision shapes become polygon based, and that just has a performance impact. And again, you know, that only matters if you have loads and loads and loads and loads of them. You know, like for instance, in my space game, it matters. In this, probably not, which is, you know, why I can get away with this being that sort of shape. But I do prefer using primitives whenever I can, because they, you know, collisions is all math. It's and figuring out the volume inside of a polygon-based shape is very expensive math, while a sphere or a cube is very easy math, very easy math to figure out whether something is colliding inside. Well, relatively easy, and you notice that in game performance. So. Alvaro, I'm glad that you're enjoying what I'm doing here. Again, like I said at the beginning, this is purely experimenting, just to get some ideas. So we're stumbling through this and figuring out what the best way is to do some things. I want to get this a little bit better so that I can show you guys what I tried doing here. Before we start looking at some of the things, just have a quick look at time. I've got plenty of time. I'm probably going to do this for another hour or two. So we'll see how far we get in this. So we have a couple of collision shapes here that works and an area. So like I said, the area is the thing that we pick up. And I've got a little thing here that actually shows us where it is. This is actually, and I hit it because we were experimenting with things. This is actually the collision shape that is with the door, and like I said, this is actually wrong. I need to make that somewhat smaller, and I want to properly go. Is that on the left? That's fine enough by me. I want to make that correct. And now here you can see the problem that our door is actually too far in. But what we're going to be doing, actually, let's have a look if we can get that like this. Let's hide our door mesh for a second, because I just want to see how is that positioned. Because I want to make sure that it's not inside of that. But I do want my collision shape to not be... yeah, that's part of the problem, isn't it? All right, let's fix that up first. Because again, if we want to do more with this, and potentially even make this, probably our static body is going to have to become, that's a good one, because that's what we want to pivot on. All right, we're not going to do that with this, but this is going to become important. And that might also be why our door is so spring-loaded, because again, it's all about center of gravity. But yeah, I wanted to make sure that this one is on the right center of gravity. So I'm going to go and move that like this, and now move that guy like that. And on the front view, that's probably going to be still wrong as well. There we go. You need to be slightly in there. I think I already made this slightly smaller than the gap, so I'm hoping that that is indeed correct. Now our door mesh itself does fill the gap, it's fine, but I saw that no, not that guy, this guy. Oh yeah, because it's not centered. There we go. I think that is good enough for what I want it to do. All right. Boom. Okay. So what I've done right now is in our area here, and I'm giving it that pivot, and ignore these because I'm not actually using those. But all that we're doing in code here is that I've implemented part of our pivot or our pickup logic. Now again, in my tutorial on two-handedness, I've actually used the object pickable script and just disabled some of the logic. Here I duplicated a whole lot of that, and at some point in time I either want to add an object to XR tools for this, so that we just have an existing implementation that we can use, or combine it with the object pickable and give it a mode where it is actually where it returns to its original position when you let go. So that is basically what it's doing here. So in our ready, Yeah, we're double checking our pivot. We're turning process off because we're only starting process when we get picked up. So when we get picked up, we make sure that we let go by anything that we were picked up by before. We figure out who picked us up by which, so that needs to be stored for our standard logic to work. We get a delta because I want to, I don't want it to snap to where I am. I want to know how much different, I know what my position difference is, so that if I move my hand around, I react to that properly. Let go does the opposite, and I'm only running my process mode if I'm actually holding this object. And again, this is an invisible object that I'm holding, and we're going to make it visible in a minute so that we can actually see what we're doing. And then in our process function, I am simply I'm taking that delta with our new position, and I'm translating our position into local space of our door, figuring out what the angle is between the pivot point of our door and where our hand is right now, and use that to move the door, to give the door an angle. The only thing that I haven't done here is to constrain that angle so that I can't push the door beyond its limits, so the door will go through things. But the problem is the door itself is a static body, so as I'm interacting with it, I can move it. When I let go, that's just its new position. It also means that if I open it against something, I can just go straight through it, which is why I can rotate it straight into itself. And that's something that I want to look at in a minute to see if we can change that and actually make that work with the physics engine. This is what I tried to do with the cupboard doors. But yeah, we'll have a look how far we get with that. So here we just do the update highlights. That's our function that, and I've just got a little highlight object which isn't properly shaped because I really want that to be the shape of this handle. I just turn it into a box. So that's this guy. Just draw a little box over it. That's just to indicate that my hand is close enough to grab it. That's all that does. So that's that. But anyway, what we're going to do is we're going to add one more mesh instance here. Not there. As a child here. That obviously is now going to be repositioned wrong. There we go. So I just want to make sure that we can visualize where we are with our area. Let's call that visualize. And I'm just going to give that a cube. And obviously that cube is way too big. There we go. There's our cube. There's my cube handles. Why can I not see my cube handles? I don't know. Anyway, all that I want to do right now, that's too small. Let's make it a bit bigger than that. I just want something that we can see where we actually are. So that's just for testing purposes. So that will see where our area is as we are moving our hand around. And with that, we can see how we are orientating our, and that is going to snap to our controller, I think, which is why I do that offset thing. So we might need to apply that offset to our visualize. We'll see about that in a minute. See if that works. Let's first go and test how much we've got working right now. Here we go. All right, so we can see a little cube there. And this is what I meant. Oh, I am too close to my real desk. Here we go. So here you can see that block that I created, and you see the little effect, and the Z buffer is not able to decide which one of those two is closer. But that is that pickup effect, that when my hand is close enough, I show that transparent. Well, it's not that transparent actually. It's supposed to be transparent. Blocked. And now when I grab it, we can see that we can move our door. But as I did in our intro, we can actually move it too far because as we're moving it, we're not actually checking and colliding with anything. Plus that our collision shape is still part of our our collision shape is a separate shape, but it's a static body, so it's not going to care whether it overlaps with other static bodies. It will obviously care, when I try and do that, and my table is in the way, where you can see when I think that is my it didn't fix up that one. I didn't save it. That's weird. That might be our margin giving us a problem. That's funny. Yeah, let's double check why that's not correct. But yeah, so we can move our door open and close. We can interact with it, but because it is a static body, it's not really interacting with the world the way that we'd like it to. Oh, close off. There we go. Now, why did that suddenly? Oh, that's the right size. So I'm betting that is because of that. I think. There we go. And again, this is really where our sizes of our physics engines are. They are troublesome. Anyway. I think that is why our positioning of that didn't work very well. Okay. Cool. So yeah, so that is one way of doing it, is where we are grabbing an object, pairing it to our controller, figuring out. Actually, I'm not pairing it to controller. I'm just remembering what the controller is. That's why actually this isn't needed in this case. I thought I did do it. I did that with the gun, where I'm actually pairing my object to my hand, to my controller, and then using its position for moving around. I think here I'm not pairing the area. I'm just saying, now I'm treating this as picked up, and what we're simply doing is in our process. Yeah, we're getting the global position of our controller, adding our delta with it, which is the difference between the original position of the controller when I picked it up and my area, so that we know how much to adjust it by. That then becomes the position that we calculate the angle and update the angle of our door and setting our transfer here. And obviously that is where I should now be using my my minimum and maximum rotation to limit that. So I guess we could quickly see if we can make that work. Okay, that is really wrong because I'm not doing. No, I am. I'm doing an ACOS here, figuring out what the angle is. Not quite sure why I'm checking if the angle is bigger than that. I think I need to make sure that it's going to be between those two. I think that's my problem, is that I'm only doing it one way around. Yeah, I think that's where I got in problems, because whether I'm turning the door inwards or outwards, I'm starting at 0 degrees, which is cosine 1. Whether when I'm pushing it inwards, my cosine goes that way. I'm just getting an angle between 0 and 180 one way, or between 0 and 180 the other way. I'm actually you need to start looking at which direction the cross goes into to figure out whether I'm going that way around or whether I'm going to go that way around. All right. We could do that. Yeah, that should kind of be checking each one of those, shouldn't it? I'm just going to assume on Y right now. So I'm going to say, so the cross is when you get two vectors, you get the perpendicular, which points upwards when we go one way around, or downwards when we go the other way around. So actually, let's assume that if the Y is negative, so our cross points down, then that means that we're going inwards. And that would mean that we're going to do angle. So we've got our angle ACOS, so that was going to be 2 times, I always forget, I think it's just that, 2 times pi minus angle. Okay, let's see if that indeed works. Boom. So I want to print my angle. What are we doing? But now we're going to say if our angle is between min and x. So those are in degrees. Yeah, let's run into unready vars. Radians is going to be back to red min rotation. So we want those between the radians. There we go. And now we're going to say if angle bigger or equal than min rotations rad and angle smaller or equal to max rotations rad. So this will only work if we are if our rotate type is Y. How did I manage to do that? There we go. Angle. So depending on whether we've got this guy the right way around, we're either now going to only be able to push our door into our cupboard, or we're only going to be able to do the right thing. We shall see. And obviously that code, you know, if I really want to use that as a standard object, I need to enhance that to also work with the other angles. Now, why am I not seeing anything in my headset? There we go. Now I am seeing something in my headset. There we go. There we go. Let's see if that makes sense what we just did. Not at all. Okay. Okay. What did we do wrong? Something big. There we go. There we go. There we go. Okay. All right. So that is interesting. Because I am adjusting my angle here, but I'm still doing that. Okay. Okay. What we're therefore going to do is we're simply going to do adjust angle is angle. There we go. And we're going to be using that one in our check, because with our rotated, because we're using our cross, we are using our angle as is, but because we've changed our angle here to give us a 360 degree angle, and obviously if our cross is negative right now, which is all to do with which way around these, where's my dot? My dot calculation is. I'm actually going to swap. Oh, let's do this first. But I'm actually going to swap those around in a minute so that our cross is the other way around. Because obviously, when we're pulling it out, let's see which one is V1 and which one is V2. Does that make sense? V1 is our start position. So that's where we were. How's the start position collected? How is our start position calculated? Because that's the other thing that doesn't seem to be right. I'm never calculating our start position. I think I need to do that over here. Because how can I ever get an accurate... That does not make any sense. I think I just want to use area. Oh, not area. Dollar. Oh, that's on pivot. I think I want that one. That does not make sense. That means that that one was always a zero vector. How is it ever been able to work? Did I really not? Because I did do it over here. Set pivot, start position, pivot. Ah, okay. That explains a lot. Yeah, absolutely. Where is my line of code? That makes perfect sense. Where is my ready function? Here we go. So we don't need to do that. Okay. So I said it. I thought so. And I had to have implemented that. So yeah. So the moment that we specify what a pivot point is, we're then using the difference between the position of our area, which is our script, and the position of our pivot point to get our starting vector. And that means that our v1 is always basically pointing in the direction towards our original starting position of our area, and then our v2 is where our hand is right now, the vector from the pivot point to our hand, and we are taking the angle between those two. Okay, that's fine. And I probably want to turn that around because I want my my rotation to be 0 when we're on the same, and then I want it to go positive as the door goes outwards and only get towards 180 when it goes around the back. Right now it's the other way around. Inwards is 0 to 120, and then when it comes outward. So what we'll see right now, I think, is that we're going to be pushing our door in and not being able to take our door out. Let's see if that theory is correct. Oh, I'm stuck with my cables. All right, let's have a look. Let's have a look. Okay. So yeah, like I said, we can't put it outwards. We can put it inwards. So, but it is working. And I wanted to make sure that worked, even though those were not the values that I wanted, because I wanted to make sure that it worked when it's the other way around. So we're just going to flip these around. And by flipping them around, by checking the other set of vectors, that will mean that we basically turn our rotation the other way around. So now our cross should be pointing upwards when we pull the door out, and the cross should be downwards when we go the other way. Which should now mean that our door should only be going... I think I'm actually going to go and clamp the angles as a result. We'll see about that. Okay, that's interesting. I had expected that to work. That is really surprising. So I do think it's going from... Let's see how our... Okay, what are we doing there? What are we doing wrong with this? Okay. That's interesting. That is weird. Seeing that we reverse both our dot product and our cross product, that should be working. But it's rotating in exactly the opposite direction as we're expecting it to. Why? I don't know why. But if that is what it is, then we're just going to flip that around and just do it that way around. That doesn't make any sense, but okay. This is a bit dirty because I'm not quite sure why it is behaving the way that it is, but if this works, then I am kind of happy with it. But I need to figure out why that, because when you, oh, there we go. At least our door closes now and opens. And that's as far as it opens, so that's 120 degrees. So that part of this works. So we can open and close our door. We can't push our door, but we can open and close it. So that's good. You can see that that is now fixed as well with our margin fix. But reversing the dot product and reversing the cross product, I thought should give us the same rotation matrix. And it doesn't. It fits our rotation matrix. So I find that surprising. I don't know why. I'm probably not thinking the logic through completely there, and I just got lucky that because I'm doing the dot product and cross product in that order, it is working. Yeah, because it's the angle that V1 needs to move to get to V2, and when you turn it around, it's the angle for V2 moving back to V1, which indeed means that we're reversing the direction of rotation, because we're basically saying, how do we rotate our hand position to our original position of our door? What rotation is that? Not, as what I was thinking about, is just flipping around the rotation of so yeah, now it makes sense that it was pushing the door inwards when we reversed V2 and V1. So our angles are just the other way around. Okay, well, you know, that's just the way it is. So for, you know, so maybe we should say that our door actually goes between 0 degrees and 280. No, is it 280? 120? No, 240. But for our example here, this works fine. Okay. Hi, Rodzilla. How you going? Yeah, the 3D math itself, is once you the problem is when you look at calculating a dot product and calculating a cross product of two normalized vectors, I know what it does. I know that a dot product gives you the cosine value of the angle between the two, and the cross gives you the perpendicular vector. And just the thing that it is that if so this is v1, this is v2, as your v1 moves that way, if it's on the positive side of it, because remember, this goes from 0 to 180, and cos goes from 0 to 180 on the other side. So when you go this way around, your perpendicular vector points up. When you go this way around, your perpendicular vector points down. And that's how you can figure out whether you're rotating to the right or to the left of your v1, your first vector. Why that works beats me. I just know that is what those two functions, how they can be used. And again, it only works with normalized vectors. If you don't normalize your vectors, your dot product and your cross product, they still have value mathematically. Don't ask me how, and don't ask me why. I know that when you look at like force mathematics to calculate the forces between objects when two objects hit, this can be used there because your non-normalized vectors, your dot product will then give a value that's related to whether one vector is bigger than the other. Don't ask me exactly. I'm not a mathematician. I really learned a lot of this stuff just by experimenting. I did love math as a kid. It was one of my favorite subjects. Yeah, I know, I'm crazy. I know a lot of people don't don't see math that way, but I do like math a lot. But I never got into it deep enough when it comes to trigonometry to really understand why these calculations do what they do. But you don't need to, as soon as you understand that what these functions do, how to functionally use them, you can do stuff like this. And dot products and cross products are just, they are heavily used in computer graphics. Let's say it that way. Because you can do a lot of fun things with it. Your whole lighting model, the simple fact that your dot product gives you the angle between incoming light and the normal of your plane. You can figure out the light intensity by simply using the value as is. Some really funky things that you can do that way. That's all because it just gives you a cost angle. And that's all that we're doing here is figuring out whether we're going left way around or right way around. If we're going one way around, we say that's 0 to 180. If we go that way around, it's 360 down to 180. And as a result, I know, how much our door would move depending on the position of our hand, and that's how we place it. So that's solution one. This solution is very stable. We can open our door, we can close our door. It's limited to its maximum open and close. But there are two problems with this approach. The first is that as we are moving it, it's not interacting with anything. The second problem is that it's static. We can't push this thing around. And in there lies a conundrum, because I want them to be proper physics objects so that we can interact with them and that they interact with the world. But you can see what happened with the cabinet door. So we're going to next look at what I've done with the cabinet door and then figure out, can we fix that? Actually, originally was planning on making a new implementation, but I think we're going to stick with this actually and see if we can make it work. Or do we need a combination of these two? One of the things that we can obviously do is when we grab our handle and we move our door as a result, we can make it behave this way. But instead of it probably being a static body, I might make it a kinematic body at that point in time so that we can move it so that it pushes other things around. But then when you let go, it becomes a rigid body and we can actually interact with it. Which may then end up having the same thing as our cup, that if we let go and our hand is actually inside of the door, that'll get messy. But here's solution one. This one's stable. This one works. Has limitations. let's have a look at solution number 2 and see if we can make solution number 2 work. So I want to close off a bunch of things because it's getting a little bit full. So let's go and have a look at what we've done with our cabinets and see how can we make this thing work the way that it should. All right. Oh yeah, it's got some books inside. Oh, that hides the whole thing. All right, so this one is quite a bit more complex, but also a bit more fun. So here I did go through the effort of breaking up my collision shapes for my cupboard. So if I go and hide these guys, those were my doors. And I'm probably going to leave one of those doors hidden just to make it easier to interact with the doors. But we can see that our bookcase, and again I did the same trick as with our kitchen cabinet, where I have hidden the original doors that come with the GLTF, and then used the meshes for the actual hinge doors. And that doesn't give us any extra performance issues because we're reusing the same doors. Still keeps them, contained within our GLTF, but it allows us to make these things work. But then collision shape wise, we can see that we've got lots of collision shapes. So we have the collision shapes for each of our planks inside. We have a collision shape for the top, and it doesn't actually extend to the edges because we have our side walls. So we have a side wall here, and we have a side wall there, and we have the back of our cupboard. And I think the only thing that we're missing is the slight little area here. So maybe I should actually make that top one encompass everything. Now our bookcase itself is a static body because the bookcase itself we can't push around and move. I could turn it into a rigid body, make it really heavy so that we could push the whole thing. That could be fun. That would give some nice puzzle options. Push the cupboard away to reveal the hidden door. But for now, it's a static body. So the cupboard stays where it is. All these objects stays where they are. Now the left door and the right door is implemented the same way. So we're purely going to have a look at what I've done for the left door and worry about that. So our left door is just a spatial, just a placeholder for our location. And the first thing that we have in here is a hinge joint, because we want our door to be, to move on that joint, but we want the physics body to work the way that it works. Now, with a joint in our physics engine, we have a node A and a node B, and those are just the two halves of the joint. So you've got a physics body on one side of the joint, physics body on the other side, and they can move in independently of each other basically, but they're joint. All right. Now in our case, our node A is our bookcase, which is a static body and therefore doesn't move. So the only part of our joint that is free to move is our node B, is our left door. So we have our left door here, and this is then a rigid body. And I think this is already where I'm having problems because of my position here. Because remember, what we just discussed is our rigid body becomes the center of our mass, and I think that's where we start seeing our problems arise. I think that's one of the reasons why it's behaving so weird. But let's go and have a look a little bit more about what is all working in our hinge joint. The first thing is that we can define an angular limit, and you can see that I haven't done that. I actually really got into trouble with this, and that is because of what it decided to be our starting point and our ending point, and I couldn't get it to work properly. So I've left that alone, and I'm actually relying on the fact that our rigid body collides with the inside of our cupboard. Now that is another thing that's really interesting, is that by default the
physics bodies attached to the joint do not interact with each other. So by default, I could actually move my door into my cupboard. It would only collide with other rigid bodies in the scene. It would not collide with the node A. You have to turn on this exclude nodes in order for node B to actually be able to collide with node A and make the door not go through our bookcase. And I think also, again, that is part of my problem. That is part of why this is actually not working right. So we'll have to see how we're going to deal with that. Because I think one of the problems that we're having is that we are getting a feedback loop. And that's, I think, why it's moving so weirdly. Yeah, tau is indeed 2 times pi, and there's a big movement around saying that tau is a much more valuable value than pi because you're generally working with 2 times pi. Yeah, I guess I could change it to tau. Old habits die hard, I guess. Anyway, so looking at the other ones, can't really remember what bias was all about. Oh yeah, and that's why I put that to 99. Interestingly enough, is that by default, if your body moves away from the other body, it tries to correct the movement based on our joint. But you can actually, by default, you can kind of shake the door as if it's sort of loose. And the higher this bias, the more fixed in position they are. So putting this bias, and I think 99 was probably the highest value that I could get it. Make sure that I can't sort of swivel the door actually stays in place. I can still do it, when you push the door in a way that it moves unnaturally, and especially with the original force implementation that I had, which we've already undone, that gave some really weird issues. So we shall see. We shall see. So that's how our hinge joint is set up, with our node A being a cupboard, which is a static body, doesn't move. Our node B, therefore the door being the only thing that moves, and therefore only able to move on this hinge. But it's now a rigid body, so it has a life of its own. It's constantly being affected by gravity, not that that does much, and it's obviously going to be affected by our controller. Now, one other thing which is really interesting is, yeah, I did give it a mass, so I made this a bit of a heavy door, 10 kilograms, which I think also is important in how things work, because I don't think I've given a mass to my hand, which will probably therefore be a default as 1 kilogram, and that might be interesting. I'm not quite sure. All right, so we don't worry about anything like contact monitor and stuff like that, because we're not actually doing anything with that. Now we do have a grab here. And I'm not going to worry about that right now. That is something that we are going to look at in a minute. But I first want to have a look at purely the interaction of the door. And that's one of the reasons why I hid the other door. And that probably also means that I should be just disabling this thing altogether. So I also want to disable the collision shape. I want to make sure that our right door doesn't do anything, doesn't play around with it, so that we can actually reach behind the door and do something with it and see if things work. Now, the first thing that I'm expecting to fail is the fact that our rigid body has the center of gravity of our door to the right. I think that might very well be one of the reasons why we're having problems. So let's take this one step at a time and see if we can make this thing behave in a way that's... Are we going to get screen? Hello? Godot is having its sweet time starting up. Alright, so now I can see one door is gone, and I should be able to put my hand inside. Yeah, I can. Alright, so that actually works slightly better than I did before. So I can push my door around. We can see that it has a tendency to fall closed again. And the other thing, which I think is still there, is this effect. So I think that is because our door moves against, you know, it's against our cupboard. And because when we're pushing it, we're giving it some speed, it's kind of bouncing back. But I also think it has to do with our center of gravity of our door being in the wrong place. So it kind of works. But not quite the way that we want it to work. All right, so let's see if this works better if we actually get it to use the right center of gravity. Let's do that first. So that's a good one. I'm going to use my collision shape as a guide because that's the other thing that I did. I made my collision shape slightly smaller. Let's actually also make sure that this guy has got a much smaller margin because that might have something to do with it. And I actually want this to be somewhat more like that. And that's all to make sure that our collision shape behaves nicely. All right. Okay. Now there's a really nice trick to get that recentered. So we're going to make our collision shape over here, which now means that the positioning is correct. Now we're going to go and move our, yeah, it's going to be complaining, but that's fine. Our left door over here, which is now incorrect, which means that I should be able to move this to 0, 0, 0. There we go. Looks in the wrong place, but that's fine. We're going to worry about that later. Now we're going to move this guy there again, so that is now properly centered. And we're going to move our collision shape as a child here, and I want to actually make that be the first one, which means our collision shape is now properly placed. We can see that the rest is now completely in the wrong place, but that's fine. So let's go and grab those two at the same time so we can affect them at the same time. We're just going to go and move them. Actually, I want to go into, no, not left view, front view. That's good enough. This is where it's really hard that the door and everything has the same color. It's hard to see where we're at. All right. Something that I actually want to do right now. So the reason I'm doing this, I want to offset the color of the door so that we can better see how the door is positioned. And the reason I'm selecting the grab together is that because I know that that is in the correct position in relation to our door. That means that moving our door also moves that correctly. So there we go. Yeah, I think that's as good as it'll get. I think I'm happy about that. Yeah. All right. So let's go and remove that overrule of our material so that we actually get a door's material back. And let's have a look if changing the center of our gravity of our door makes any improvement on how our door reacts. Yeah, no, it's good to be aware of tau, and it's purely a matter of, you know, not just knowing that it exists, but also getting used to actually using it. All right. But yeah, because now when you go to school, that already behaves a lot better, doesn't it? Look at that. So this is where I think we're pushing it too far through the edge of our door. So this is where our collision shape actually moves into our cabinet. It's interesting that it allows us to do that because And you can see that we're actually disjoining the hinge. You can see that the door actually sort of pivots around the collision shapes instead of it just stopping. And I think that's where our angle minimum maximum is going to come into play. But other than that, just fixing up... Oops, that was my monitor that I hit. Okay, again, here you can see the same thing. This is that bias that I was talking about, where I'm giving an unnatural push to this door, and as a result, it just moves in. See that? How weird that is. But other than that, if we don't push it beyond its limits and into the... Yeah, so it basically works unless we try to force to push it into a place where it doesn't belong. Where it, instead of it just stopping, it is still moving. So I wonder what we can do to make that happen. Other than that, putting our center of gravity properly has made the door work really predictably. All right, that's pretty cool actually. I'm really happy about it. Now, one of the things, my cable's getting stuck in, yeah. One of the things that I think that we need to fix is the weight of our grab. It's this one, isn't it? So yeah, I don't have any weight on this guy. It should really become a setting here. Let's connect it. Collision. No. That's really interesting. A kinematic body doesn't have a weight. Really? That doesn't make sense to me. Because the weight of our kinematic body, if you push, because that's what we're trying to do here, right? We're trying to make it a push action. Does our move and slide logic have any knowledge of weights? That surprises me. Because your ability to push another object is going to be affected by how heavy the object is that you're pushing. But we don't have anything here that gives our physics engine any idea about how much force we are able to apply to something. Would that just purely be a factor of how far we're trying to move into our object? That's really interesting. I don't know the answer to that. I don't know bullets well enough to know whether we're just giving bullet a fixed value because Godot never had that value in its own physics engine, or whether that's just being ignored. Which would mean that whether we push against a heavy object or a light object, we would move it. It's like giving it almost an infinite amount of force. I'm not sure. That's interesting. I don't have an answer to that. All right. But whichever way around, I do like that our door behaves more consistently now. So yeah, we do have the weight on the door itself. Right. So let's see if we can use our angular limit to make things work a little bit better. And you can immediately see that it makes this really weird look of this. And I'm not quite sure how it's expected to do this. Oh, click in the wrong place. So does this mean, putting this to 0 and that to 90, that we're now able to move it no deeper, but up to 90 there? That's what I wonder at right now. Let's see what it does. Let's see if this does anything sensible. Because it's not very clear from the UI what that upper and lower limit actually, how that is supposed to be set. So let's see if we've made it do anything that makes sense. So we can move it there. Oh, boink. Why does that now? Well, that definitely didn't do what I thought it would do. But again, one of the things that I'm wondering about. Okay, let's do this. Sorry, 10 and minus 10. I just want to see what we can do now. Because again, I wonder if we are moving it into the negative. And we're always... And I'm also wondering, does this mean that just it's a hard limit? Or that it tries to move it back to that? So what you can see here, we have the 10 degrees of motion. But then we can push it over it and it tries to spring back to it. So it's not a hard limit. But we are going from, and that also means that I can go in there and it tries to push it back. Okay. So I'm guessing that if we put this to minus 90, oops, and we put this to 0, we are now making sure that we can only open it to 90 degrees. But it's not a hard limit. So does that have something to do with our relaxation and our softness? I think we're going to go and do some more research in our docs and see if someone actually wrote some documentation about this. Helps if I write it correctly. All right. Max rotate, only active if enabled. Minimum rotation, that's fine. The speed with which the rotation across the axis perpendicular to the hinge points get corrected. I think we're going to go and make that real high. Doesn't say anything about softness. The lower this value, the more rotation gets slowed down. All right, so let's see if we put the bias really high. Let's see if that makes any improvement to our simulation. Oops, picked up one of the darts. All right. Let's see if that's improved anything at all. Okay, so we can go to past 90, but it then tries to, at least it doesn't go real crazy now, so we can see, oh, a little bit. You can see that this adjusting is a little bit less crooked, but you can still see we can push it over its limits. And I'm presuming we can also do that there. And when we try and push it over its limits, it's definitely, I really wish there was a way to say to that joint and say, I honestly don't care. Don't move over your maximum value. It is what it is. Okay, so what if we put the softness down? Let's try that, because that's what softness sounds to be. So maybe if we put the softness down, we actually can't push it beyond its boundaries. Let's see what softness does. We should make a UI that we can actually, yeah, maybe we should do that. That we can actually change that. No, it's still kind of behaving the same way, isn't it? Okay. Yeah. We really should add a UI in there. I don't really want to waste time on that right now. But I think that's something that I'm going to do as part of my, when I do this as a tutorial. I'm actually going to make sliders for that in-game, so we can see what those do. I don't really want to... Okay, so let's go and put relaxation down to low and see what that does. What does relaxation do? Yep. Pushing it against myself. Still can just go. Whatever we try, it always makes it that we can just push it through it. It just doesn't make any sense to me. Why would that even be a thing? Why would that even be logic? That we can take it out of its maximum. Other than that, it works. You know, within its constraints, it works really, really good. It's when we try and push it out of its constraints that it starts misbehaving. How do we? Oh, that's still disabled. Okay. How do we change that logic? Does not make any sense to me. This works perfectly. If only it would just be that it does not allow us to move beyond that. I really don't get it. I really don't get that. You know, we could always fake it. You know, that's the other option. You know, have the hinge joint move an object that's actually invisible, that's purely there to make the hinge joint work, and then adjust the door to follow, but within its constraints. That would be really ugly to make it work that way. All right, what if we put our bias to highest, softness lowest? Let's put our real. I want to see what happens when we put our relaxation all the way up. Still don't think that would make any difference. Hi Bailey, thanks for joining us. We're doing pretty good here. I hope you are good yourself. Yeah, so kinematic body isn't affected by physics, but it does affect rigid bodies. And the thing that I don't get is, in order to know how much force you're applying to a rigid body when a kinematic body hits the rigid body, so when your player hits the rigid body, is kind of important. Now, obviously, one of the things that we could do, and that might actually be one of the things that we will try, if we can't make this work properly, is we don't actually use kinematic bodies for these things, but we use rigid bodies, and we move those in some other way or shit. Whoa! What happened there? My door's gone. Where did the door go? What the hell? Okay, so that relaxation value is not a smart one to set to 16. I don't know what it's supposed to do, but no more door. That was I don't know where it ended up, but that door's gone. Okay, so definitely relaxation. I'm gonna turn you back to 0.1. All right. All right. I want actually our lower angle to be a little bit more. I'm going to try if putting that back to the way that it was, that door doesn't fly off anymore. And I'm going to try and see if we can make our follow ball work with a different type of element. I think that's a good idea. Now we don't have a move and slide with rigid body, so we're going to have to make our own. It's going to be interesting. So yeah, so again, it works, but we can do crazy things. Wow. That was weird. Okay. Yeah, because I really wonder, is it the fact that our kinematic body allows us to do something beyond that? The problem is, how are we going to... Because the rigid body works with forces, right? So how can we make our rigid body follow our hand? That's going to be the troublesome one. How are we going to figure that out? And that is even assuming that is the solution. I don't know. All right. Wondering if we should be implemented as a custom integrated element. If true, internal force integration will be displayable like gravity and air friction. Other than collision response, the body will only move as determined by integrated forces. Called during physics processing, allowing you to read and safely modify the simulation state for the object. By default, it works in addition to the usual physical behavior. But the custom integrated property allows you to disable the default behavior and do fully custom force integration for a body. I've never done this, but I do think that we could potentially create our own integrated forces method that basically calculates the movement required for our rigid body to follow our hand, basically. I'm gonna have a quick see if someone has actually got something online. As an example of how you would do this. Yeah. That's actually probably all that we need to do. So we know what our current location is. Well, we know what current location is of our rigid body. We know what the location is where we want our rigid body to be. And we can just set the angular velocity to whatever the velocity needs to be to get it there within one step. And then let the internal logic do what it needs to do. Now, I don't know if we can just change the position. Although I think the whole idea about integrated forces is that we can safely change things there. So that's something to try. All right, Brent, welcome first of all. I am running different setups. I've got an index here. I'm currently today using my Rift S. And this machine that I'm running on right now is a pretty powerful one. It's a laptop with an i7 Intel processor. And more importantly, it's got a 2070 RTX NVIDIA card inside. So it has more than enough power to do anything that I want to do with VR. But what sort of FPS you're running is incredibly dependent on how well you build your game. So when I look at this project that I'm doing here, I haven't really done much optimization on this or anything. It is quite simple. On my other laptop, which has a 1060 GTX, this runs on 90 frames per second with everything that it does. But doing one thing wrong, I can easily get that frame rate to just tank. And it's actually, there's a lot of factors involved there. Anything from using lots and lots of physics objects, seeing that this is very physics heavy, what I'm doing here, which have complex physics shapes, which is definitely something that keeps the CPU very busy, to, you know, just putting objects inside of the world that are not optimized. You know, one of the good examples is the other project that I'm working on for my Friday night stream, which is my space game. I have a space carrier in there, which is quite high poly, relatively speaking, but it's also a single mesh, which means that it's rendering way too much when you're inside of the carrier, when you're in the launch bay. And you just, you know, especially in VR where you're trying to hit 90 frames per second at the minimum in stereo on high resolution, doing that sort of thing will kill your performance. It has nothing to do with Godot. That has to do with, you know, that would go wrong with any other game engine as well. It has to do that you do have to know what costs performance and how to optimize for that. So when we look at our space carrier, a really important thing is it shouldn't be one single big mesh. It should actually be broken up into parts. It can be a single mesh when it's far away, and then it should actually be a much low poly mesh with none of the interior inside. But when you're inside, you want to have everything broken up so that you can actually have your culling logic cull half of the stuff that it's rendering that it shouldn't be rendering, and you get your frame rate up. So again, frame rate wise, there is a lot that has to do with what you're doing. The other thing is, you can see that this project is running the GLES 3 driver, which is a relatively expensive driver because it does a lot of more modern lighting techniques. So in my space game, I've specifically chosen to go for the Glass 2 implementation because it doesn't do a whole lot of that. So I get rid of a whole lot of overhead that I don't need in a space game. I am looking forward to working with Godot 4, which has the new Vulkan renderer, because it will allow us to do a lot of the lighting stuff that the Glass 3 renderer offers, but without the performance penalty. So, or with much less performance penalty, I should say. But yeah, it is not a question that you can easily answer, because there are so many factors involved. Obviously, Unreal specifically, and Unity to some extent, do have more optimizations, so it does more out of the box for you that in Godot you have to figure out yourself. A good example here is something that I discussed at the beginning of this video, is we can only be in one room at a time here. And when I'm in the living room, I'm never going to see that bedroom. There's no way I can see that bedroom while I'm walking around here, especially if the doors here would be closed. The same with that bedroom over there. I'm still rendering it because it's still part of my scene. So you can introduce methods that will hide large parts of your scene if there is no way the player can see it. A lot of game engines do that automatically, but at a cost. This is what a lot of people forget, is you do have techniques like occlusion culling that will, especially if things are properly set up, will cull a lot of objects out of your scene that you can't see and therefore shouldn't be rendered. But that in itself, because the game engine has no idea of your logic and your structure, that in itself might actually introduce new performance overheads. So it really depends on what you're doing, which techniques become effective. And of course, when you build your own game and you make decisions on that yourself, you have control over that. So yeah, lots of things to think about, lots of things to look at. But when you look at something like this, that's a bit hard to say, because right now I am running on my higher performance laptop. But like I said, even on my 1060, this project runs pretty decently. Especially because, and this is one area where there are some, where there is room for improvement, let's say it that way. I chose specifically to do this project with my Rifts, because the way that the Rifts SDK works, the Rifts SDK is much more ended to performance than the OpenVR SDK. OpenVR is much more geared to convenience to the programmer, to get a VR game up and running very quickly. And you notice that. I actually, running my Rift on OpenVR is quite a lot slower than running the Rift directly with the Rift SDK, because you're cutting out the middleman, so to speak. And I'm very interested to see how that's going to be affected once you start running stuff on OpenXR, because OpenXR again is much more performance conscious than OpenVR was. But it means that you as a developer, well, me as the guy who wrote the VR plugins, we have to do the extra bit to make it work. Time will tell. But I have great hopes for that, actually. I'm playing around with the OpenXR driver that Christopher Haag made, which currently only runs on Linux. I've almost got it run on Windows. Just need to find the time to actually round it off. It's just been very busy. But yeah, I've got some high hopes that would solve things. That said, OpenVR running on the Index, runs really, really smoothly, because again, we don't have that middleman there. OpenVR having to talk to then the Oculus setup. There's some copying of buffers going on, and OpenVR with the Index doesn't do that stuff, because it's all directly implemented in OpenVR. So that's kind of interesting. So yeah, so those are the kind of things that that you do have to keep in the back of your head. But in the end, the performance is really how well you structure things and what you choose. If you go for expensive lighting techniques, if you add in GI probes, which I did in one of my original projects with the VR episode tutorial, you kill your performance because those techniques are not meant for VR. There's way too much overhead. You can't reach your 90 frames per second, stereoscopic rendering with those techniques unless you have really beefy hardware. So, yeah. But you have a choice what you want to use. Because also, like I've said many times, one of the main reasons why most of the popular VR games don't use very realistic graphics. You look at Super Hot, and you look at what you call that other game? I always forget. The one where you need to do all sorts of things. Job Simulator. They all have fairly straightforward, old-fashioned graphics and concentrate on gameplay instead, which I don't see anything wrong with. But it's all because performance in VR is a difficult subject. Okay. We were trying to do something with our follow thing. And I'm not quite sure what we're going to be doing here, but we will see. All right. So I'm going to make my life easy, and I'm just going to go and change the type here to rigid body. And well, I've got this all in the VCS anyway, so I can just remove that. So we're going to go and take our physics process out because we're not going to be using physics process. But I want that code in there just in case this is the wrong way to go. And instead, we're going to why am I not writing that right? Actually, let's copy this whole thing. There we go. So we're going to go and implement that. All right. I'm going to make our hand a bit lighter. That's fine. I'm going to say custom integrator because that's what we want, because we don't want any of the gravity logic. All right. I'm not going to worry about all that stuff for now, but I am going to go. Let's actually go and do that. So if we're not enabled, we're not going to be doing anything. Probably need to set. No, I'm not going to worry about that for now because we've already. Oh, we're already always enabled. All right. Actually, I don't need you because I'm not going to worry about that at the moment. So that's how much we need to move. That's our state. All right. So I guess we're going to do this all on our physics state, aren't we? So we're just going to go and update our linear velocity to our move. Let's just do it that way. Let's see if that works. I got no idea. So again, I need to put the logic in here that if we move too much, because we teleport or whatever, we're actually not running this logic. But for now, I'm going to not worry about that. I'm simply going to say linear. Why does that not auto? Because that's on the state. Linear velocity is going to be move divided by state.get step. Does it get step? I thought it was get step. Or is that from my rigid body? No, it's not from my rigid body. We're just going to go and use step. Why not? So, very important to know that our physics always works in a what you call it? In a fixed step size. So in this case, we've fixed our physics engine to run at 180 updates a second, which means that the step size is going to be 1/180th. Fine. As a result, because this is all calculated. Sorry, I've got something not being nice to me here. There we go. My desk was coming apart. Okay. So what we're taking here is we're looking at the position of our controller, our current position of our body. So we want our physics object to move this far. Now, our linear velocity is our speed at which our object is currently moving per second. But we're going to only, our physics is only going to calculate the step, or the amount of time that that will pass in our step, and we want it to move our move distance in that amount of time. So by dividing it by our step duration, we're actually going to get a velocity per second that will result in our physics engine trying to move our rigid body to the location we want it to move to within one step, but doing all the collision logic that it needs to do that. So yeah, that should work. Now, yeah, the thing that I'm worrying about, the thing that I'm thinking about is that we are running our physics engine at twice the frame rate of our actual game. So we're getting updates of our tracking every or 90 times per second, so every 1/90th of a second. So basically this ends up that one physics step we're going to move our object to its new position, and the second we're going to stay there. So we're actually making it move twice as fast as it should. And I'm wondering if that's smart. Let's just see how it works. If this even works. But if that turns out to be a problem, and that will only be a problem seeing that we will hit something too direct or with too much force. But if that does turn out to be a problem, we can always calculate our required velocity in our process function, because there we are getting our real position change. And it might mean that we're going to be a frame behind on what we're doing, but that is something I'm not too worried about, because the user is never going to actually see how we're colliding and what a collision object is. So having a small delay in that isn't actually such a problem. But the big question is our logic working? And I don't think it is, because our little ball has gone. Okay. They're all there, so they are not moving. Now that means that our integrated forces logic is not working the way that I expect them to work. That's interesting. Okay. Does that mean that we actually need to implement the movement in integrated forces? or does that move that mean that our linear velocity isn't being calculated correctly? That's the big question. Yeah, Brent, I know how you feel there. Yeah, that is always a problem. I found so far that most of the things that I do behave the way that I expect them to. So unless I'm getting, like the carrier for me was a really good example where I'm getting an object from a third party, something that I bought. So you can't blame the third party; they just make their assets available, and it's just not optimized for my use case. And then you need to spend the time if you want to. Now, in this case, I don't. I've left that alone because I'm planning to replace it at some point in time. But you're left trying to figure out what to do. When I look at this project, for instance, now I'm in the luxury right now that I don't really have to worry too much about frame rate. I know there's a lot of stuff that I can do to make this more performant. But, it runs fine on my computer, and it's not the goal of this tutorial series. This tutorial series is not about how to make get the best FPS for your VR game. It's about how to work with physics and how to interact with objects. And in games like that, even when you're developing a game, that's the approach that you take, right? You build your game first. And then you start looking at, okay, what are the parts that aren't performing and how can I deal with those? And then look at strategies. But there are also cases where you just hit those right away. And a really good example for me was in my space game was that I replaced the collision shapes of my NPCs from primitives to polygon shapes or tri-shapes that were based on the actual object. And even though I was using I can't remember exactly what it's called in Godot, but there's an option that you have to create an approximation shape. So something that doesn't exactly fit the object, but sort of tries to create a volume that encompasses the object. So you get something that's pretty low poly, or pretty low tri, I should say in this case, for the object that you have, but it's still a collision shape that nicely encompasses the object. But even doing that, because in the space game currently I have thousands of asteroids where the closest ones we actually have collision shapes for, that just completely killed my performance. And while I know that that is a problem that I need to solve down the road, because I do want to have a good strategy of getting usable collision shapes on my NPCs. Right now, I haven't done the work on the asteroid system to really make that performant. I haven't spent that time yet, but I know that I'm going to have to do that. And that really is one of those which is a good example of what you just mentioned, where you find yourself sinking hours and hours into a solution of something where you're sort of going like, why isn't this just working? But at the same time, I'm building a game that is very specific, in a general purpose engine. So the fact that I have a very specific use case that I want to work in a certain way, it's kind of understandable that's not supported out of the box, and I actually need to build something for that. You look at Unreal. Unreal, I think, is a really good example of a game engine that came out of FPS games and does everything that first-person style game requires out of the box really, really well. And obviously, that's an engine that has 2 decades of development time behind it right now. It's been around for a while. So there's a lot in that engine. That means that when you grab an engine like that, there's a lot in there that just works out of the box, and that is something that Godot still needs to catch up on. Although I also know the opposite. I've seen especially in the indie scene here in Australia, I've seen people struggle immensely because they don't actually understand. For me, I came from a background of actually building these engines as a hobby, so I know why certain things don't perform. And you now have a generation of developers who skip that. They come, they learn how to build games out of tutorials, out of following a course in an engine, but they don't actually understand what makes that engine tick. And very often, especially for good engines, that doesn't matter. That's kind of the purpose of using an engine, is that you don't need to learn those things. That you can assume that people who have spent that time learning those things have built in the logic that prevent you from having to figure that all out yourself. But it also means that if there is something that no engine does well because it's something that computers just don't do well, and you're not aware of that, you can really get into trouble. And this is something that I've really seen in the indie scene in Australia. I've seen run into a couple of people now who have really nice games that they're working on that just don't perform. Even if they run in Unity or Unreal or something like that, they just don't perform. And it's got everything to do with them not understanding enough about what things actually cost performance and what things you therefore can't leave up to just the engine to solve for you, that you actually have to know a bit more about and optimize. Then again, I also firmly believe in the opposite, in the sense of, if you are a team like that, build your game. Don't worry about the performance. If you have a really good game concept and a really good game, you're gonna hit a point where enough of that is finished and it's running on good hardware. You just need it optimized for lower end hardware to reach a certain clientele, a certain group of gamers. You can always then hire someone who does know what things cost performance, who can have a look at your games or the game that you've built and sort of go like, okay, you got to do this and this and this to make it work. I do have to say, especially, nobody knows yet because we've only seen the promos. But I do have to say I'm impressed with how far a game engine like Unreal goes with taking those things that people usually don't know about or don't do right, and building strategies into the engine to improve those performance bottlenecks. And who knows, Godot might get there at some point as well. Yeah, like to a lot of B says, it's all about knowing what things work on computers and what computers can't do, and knowing how that interacts with your game. And Unreal has got a lot of knowledge built into it by a lot of people who've been in this industry for a long time. But even Unreal does not safeguard developers from a lot of bottlenecks that people just aren't aware exist. Okay, so integrated forces. Maybe this whole thing isn't running. It's possible. Let's try that first. Let's have a look. This is gonna flood our. See my OCD there, bees? I keep putting those tabs in. Okay, linear velocity. No, actually, I want to just put move in there. This is gonna flood our output, but all that I want is to see what it does. All right. And actually, I'm not even going to go and where are you? I'm just going to hold you up. And that's all that I want to do. I just want to see if we have output. Look, we have no output. Ha! So, what did we do wrong? because it's not on. So we got our custom integrator set up. If true, internal force integration will be disabled by gravity air friction for this body other than collision responses. The body will only move as determined by the integrated forces function if defined. Now, the problem that we have is that integrated functions is a callback on the node, and our script lives in the wrong place. That is why this is going wrong. So we need to have a helper script on here. Why not? Thing has to have a name. All right? Thing has to have a name. Well, okay. Alrighty. And that means we're gonna do this a little bit dirty, but that's okay. We're gonna leave that in there. All comments out. This is now gonna move into our follow body like that. And I deleted our ready a little bit too quickly. Actually, you know what? Let's do that. Unready for follow get node. I know. This is dirty. Boom. All right. So we're going to go and follow that node, which is the parent of the parent. That's why we're doing that. Which means this now needs to become a follow global origin. And this is now ourself. This is now us. And so let's see if that makes it work. Don't know. We'll see. Oh, because the line was commented out, the line before, and therefore I didn't know how to indent it. All right, so it is following, but my performance is gone. What the hell is going on here? All right, I do want to see. Well, our problem isn't even solved, so. Yeah, I have no idea why that killed my performance. But the most important thing is our problem exists. So we're going down the wrong path anyway. Okay. So let's return this to the way that it was. Let's change that back to kinematic body. There we go. That means we want to go and clear this script. We don't want you anymore. Bye-bye. I'm going to delete that in a minute. So I'm guessing that calling GG scripts out of our physics engine like that is probably very inefficient. Although I'm incredibly surprised at that. I have to admit that. Where did this go? Because I want to delete that file that we no longer need. Okay. Is it in here? It is. Delete. Okay. Let's make sure that our logic is still working and that we didn't change one more thing that we need to change back. Everything is... I don't know how much of you you guys could see that in stream, by the way, but I could see that my frame rate had dropped dramatically. I actually need to have a frame rate indicator in here. That would probably be a good idea to add. My frame rate was just absolutely gone. All right. So, but the most important thing was that when I did this with our rigid body implementation, it was still allowing me to crap this whole thing up. So, boink. So yeah, I don't know. It's ow. I'm again too close to the thing. There we go. I don't know what to do about this. I don't know how to prevent the hinge joint from, letting me move the object further than it can move. I just want it to react that once it hits its limits, that it just basically becomes a static body. That's really what this should be doing. So yeah, that's a bit of a shame. Now, okay, the last thing that we're going to do is we're going to make the handle work again, because I broke the handle. And then I think we're going to call it an end for the stream for now. Well, we're going to have a look at how much time we got left, because I kind of want to experiment with drawers as well and see if because there's a different type of joint for sliding things. I want to see if that has the same problem, because I am not happy about that. This should just say I have moved far enough, I'm just not going to move anymore. The fact that it's just so weird. I don't know why it does that. Because other than that, this works brilliantly. I can push this thing open and closed, and it will. So yeah, weird, very, very weird. I don't know if that's just a limitation of the hinge joint or if something else is going on. I don't know. Yeah, I wish I was coding every day. Well, I am coding every day for work, but that has got little to do with Godot. Yeah, it's almost 4. Actually, yeah, we're gonna make the handle work, and then I think I'm gonna call it a day for today and think some more about how can we make this work better. And obviously, I need to duplicate the changes that we've made to the right door. At least I now know how this works, and actually, I do want to make this less. So I'm going to make it 100 degrees. So I do think I need to play around more with the bias functions and see if we can maybe get it to work better that way. Same with softness and relaxation. I don't know. But yeah, if anybody has any ideas of how to make the joints work more predictable, I don't know. I'm really surprised by how loosely coupled these objects are. Okay. So the last thing that we need to do is we need to work on the grab. So the idea here is again making something work the same way as we did with our handle on our other door, where we use our pickup function of our controller to figure out that our handle is in range, and it then allows us to pick up. So you can see it has again those things updated: pick up, update, highlight. So I don't have a highlight shape in this case. Why is my mouse suddenly stopped working? Hello. Here we go. Back. Let's actually put in a highlight shape here, just so that we can see what we're doing. Not mesh instance. Here we go. Right. Come on, I want it as a child of this. There we go. We're going to create a cube mesh, which is way too big. Alright, is it just me or do the handles no longer work? Okay. That's good enough. That one I want to keep like that. Maybe a little bigger. There we go. I'm not gonna make that a nicer object than this right now. I just want something that becomes visible when we're in range, so that we have some oh, that's actually there we go. Visible. That becomes visible when our hand gets in range. Just so that we see what we're doing. I think that actually needs to do a little bit more than that. Let's see where our where's our area thing? Kitchen sink. This guy. Oh, yeah, that should be enough. I thought I needed to check some more. So just so that we have something visible when we can actually grab it. Now the way that this works is the same as the other one, where when we grab it, we record it, we get that pickup delta. When we let go, we reset all that. And then in our process, we are checking whether we're picked up by a controller, and our parent is a rigid body. I have no idea why I'm checking that. Because our parent isn't a rigid body. Oh, that's the parent of the grab. So right now, there's this guy. I don't know why I'm checking that. That's probably me just being safe. I'm getting an impulse position, figuring it out, then a direction, figuring out in which way we need to work it, and then I clamp it for some reason. It shouldn't really work. So all that I'm doing here is I'm trying to apply an impulse on my parent, which is the door, by taking the location of the door, and that's probably why this is not working right. Because this is, I think, why I made the origin of our door equal to where my handle was. Okay, and our delta here, right. Rigid body, okay. Apply impulse. Is that a global position or a local position? I think that's a local position. Apply impulse. Applies a positional impulse to the body. An impulse is time dependent. Yeah, that's fine. Applying an impulse with frame rate dependent force. That's fine, which is what we're doing because we are scaling it based on what we're doing. Okay, so we're using the rotation of the global, or okay, it's centered on the object order, which is actually great. That's fine. But this is wrong. Pulse position. I actually don't want to do that. delta is calculating there. That would then always be on. Yeah, no, that should work. Yeah, I think that should actually work. Hold on, let me read it again. Just use the rotation of the global coordinate system. The centered. Yeah, and exactly. So it's centered at the object's position, and that's not what we're doing here. I think we're going to make this always work on where our area is, and then make it point to where our controller is, which we're doing with that direction. So I'm actually going to rename this and say this is going to become controller position. And here we're actually going to do transform.origin. Now, remember, our grab is a child of our door, so our position of our grab is actually our position relative to the location of the door. Now, no, but in global space, hold on, that needs to be in global space. That's annoying. So we're going to do global transform origin, and we're going to take away the parent global transform origin. And that means that our impulse is always going to be on where our handle is, and the strength of the impulse that we're giving is going to be based on how far away our controller has been pulled from that position. And that's why what we're doing here is where we're getting our controller position, but in relation to our delta when we picked it up, so that we're not going to snap it straight to the controller. And then our direction, that's one under there. And our direction is going to be from that position that we just calculated, based on our location of our grab. So that's really interesting. Okay. Let's have a look if that really works. No idea if it does, but it might. Whoa, what are we doing? No. Oculus is having its sweet time starting up. Okay. I think Oculus might have crashed. Close. Film V2. Restart it. Let's see if that made a difference. Wow, I don't know what's going on with our good friend Oculus, but it's not happy. Oh, my Godot crashed completely now. Okay. Okay, let's start it up first. Yeah, I think let's restart my... Yeah, man. Yeah. Are you running? Still starting up? Yeah. Yeah. It's working again. All right. Sometimes Oculus gets a little confused when you keep jumping in and out of programs. There we go. And I'm back in business. You guys can see what I'm seeing as well? Yep, you can. Alright. Alright. Whoa, what happened? We broke into code. Okay. Set something on... Where are you? Okay. Why? Because it probably didn't save that, did it? It probably didn't save it. That sucks. Where are we? Where is our living room? Here we are. And now our cabinet. This guy. Oh, we got two of them. That's right. So even though that one is currently disabled, it's still running through the logic. So obviously, this is why you turn those things into subscenes normally. Paste. There we go. I think that'll solve our problem. Okie dokie. Now have a look. Okay. So when we come close enough, we can see that a little block appears. That allows us to know that we're close. And now when I grab, I can open and close our door. Now we can see that our impulse does mean that it's like a little springy. Now here you can see that the door actually, even though I'm still providing an impulse, it goes fine. So it's that move and slide that is somehow giving it far more force than it should. And that actually works. So applying a force on the door to make it open and close works fine. Maybe that's why I originally went down the path of actually applying a force when we collide instead of letting it do the impulse thing. So maybe that is the right way to do this thing, because especially now that I've got my door working on the right, on the right balance, maybe that is the way forward. That it does explain why I was doing that. Shall we test it? Let's test it. Let's go back to the original solution that I had, because maybe my whole problem was the fact that I didn't have my center of gravity of my door correct, and that was why it was working so weirdly. So now I'm a little upset that I was dumb enough to delete the code when we were moving it around, but luckily that is why we have GitLab. That's a good one. Godot. Object interaction VR. There we go. So that's in here, I think. Not an objects, no, a MISC. Follow. Here we go. You're probably going to have to fix up all the tabs in that, but that's okay. Oh, what? Didn't copy the last bits. There we go. All right. Ah, it has done all the tabs properly. So we need to change that back to false. So this was my own solution for applying forces to whatever we push against instead of actually pushing through. So now our move and collide does not imply inertia, so it actually stops on the object that it hits. But we now get collider information, and if we're colliding with a rigid body, I am now applying a force depending on how much we've moved. And I think here that probably needs to change. That needs to be tweaked a little bit more, where we're not using the movement of our hand, but we're seeing how far through the other object we've moved. Because now we know how far we moved. We haven't moved the last little bit, so if we get the remainder and we use that for our strength, I think we get a bit more predictable behavior. But let's go and have a look whether this already improves what it is that we're doing. Now that does mean that we need to go and test out our little cup again. So we still have that we stop on solid objects, so that's good. But now what happens? Yeah, so this is where we get that we're not applying the force that we should be applying. So that's definitely something that we need to start looking at. That's my other controller, which is not being tracked right now. But let's see how well that works in our door situation. So we can now, sorry for having to move back and forward, we can now move our door correctly. All right, so again, that is, I think, our only problem right now, is that if we move further, we're increasing our strength, and at some point, I think that is at minimum distance actually, we're letting go, and we're still applying that force, so we're putting tension on the door. But, okay, so I think I need to change my minimum move distance. Other than that, our door is behaving much better. So, okay. No, max distance is 0.5, so that's half a meter. That wasn't half a meter. So at some point, maybe that's because that I'm doing that max impulse. Not sure. Okay, one problem that we have here and I think that's why my cup flew off, is we're taking how much we want to move from where we are right now. I need that ping pong ball for this. But we're trying, let's say that we moved our controller from here to there, right? But our controller currently is resting against an object. So we're actually not moving at all because we're being stopped. We're being blocked by whatever we're moving. Now we have two issues. One is that I am taking that whole movement as a strength. But the second thing is, even if I just tap it slightly, I have my diameter of my collision shape that I will never move. So our real movement is from the edge of our collision shape and that's how much we stopped. So I don't think that really is our problem. But I do think I need to actually recalculate this. I actually need to do this twice, I think. Oh, or did that not copy? We have moved. We have potentially some distance. See how much movement is remaining. So if we haven't moved at all, that will be the same. Yep, of course. Just gonna update that. So if we haven't moved, if we're actually in rest, because then obviously our updated move will be the same as our intention, how much we intended to move. But in this case, if we have moved and then we hit something, then we're now calculating just the remainder of how much we still wanted to move. Now, if that is going to make a difference, I'm not sure, because okay. Because I think that the other problem that we have while we suddenly flip through the door yeah, that is because we're not actually... Oh, that's mean if that's true. Okay, what I think is happening is we've got a controller, we've got a collision circle, which is quite small. Now, when we're moving it, we're the way that the physics engine works, the way that the move and collide works, is I've got my physics object here. I'm then looking at where it ends up, and if that collides with something, I am detecting how much I can move until that collision happens. But if my my door is stuck, my collision shape is stuck over here, and now I've moved my controller far enough that the new position no longer collides with the door, I'm just jumping over the door, or I'm jumping through the door. Which is that that continuous integration testing that we have on rigid bodies. But I don't think we have that on here. If that is true, we are going to need to break our move and collide up and move our thing no more than the wow, okay. Yeah. I guess we're going to have to build some logic there that we do multiple checks and actually move it bit by bit by bit. Because again, normally we assume that we're not moving that far anyway. But yeah, I think we're jumping through the door. And of course, because we are doing that force, you get this balance of force, right? The door, we're pushing on the door gets forced back from the fact that it can't move any further. And the moment that suddenly we snap our collision shape through the door, that negative force, that action is equal to reaction, that is what flips our door in the opposite direction. Okay, we can do that. Let's try that out, see if we can make that work better. And I think that's where we're going to call it a day. But yeah, all right. So, all right. So instead of doing this in one go, we're going to do this based on our collision shapes radius. So we want to grab that first. Let's go like this because I need to be able to see it. There's a collision shape. Radius. I'm just going to take that margin out because that's going to cause too much trouble. That's what we get for undoing things. All right, so that's our radius. So basically, we should be moving. Let's do the full 4 centimeters in this case. That's fine. So let's go and make a new variable for that so that we don't have to calculate it every time. Move step. I am going to give it a default, but that is not really needed. So what we're going to be doing here is we're going to get our collision shape, and we're going to take our radius, and we're going to do it times 2. So we want to move no more than that distance along our movement vector, and do a move and collide that way. And again, this is pure theory. I might be completely wrong in my conclusion here. All right, so we have our move here. We have our move length already. All right, so what I want to do here is I want to go and normalize our movement vector. There we go. And now what I want to say is that while move len bigger than 0, so as long as we still have something to move, we're going to repeat this. So obviously this now needs to be indented. All right, there we go. All right, cool. And it also means that we're going to use new variables there because else we're going to get in trouble. But we'll deal with that in a minute. Although, you don't really, just go and give a return over there. Make sure that if we collide with something, we don't check anything further. Here we are now going to see about our real collision. So, what we're going to be doing here is, first of all, make a new variable. Is how's this done? Move. Let's call that move part. Why not? And that's going to be move, our normalized vector, times what do we call it? I forgot it. Move step. So we're going to say times move step if move step smaller than move len, else move len. Did I remember that syntax right? Because I only used that yesterday for the first time. Cool. So basically we're saying we're going to check our move this much if our move step is smaller than our move. Or else we're going to do the remainder, our move len. So if the remaining movement, if move len is smaller than move step, we're using that. So now we're going to go and update our move len to be, actually we can do the same thing there. Move len minus move step if move step smaller than move len, else we're going to set it to 0. So we don't want it to be negative. And that means that if we then don't have a collision, we come back to our while, and that's the end of it. So now, if we've moved, let's say that we've moved a centimeter, we're checking, and then we're checking at the end. So we're gonna check in multiple places. So that is under the theory that we are skipping through our door. Might not be, but I might be completely wrong in my conclusion here, but let's see if that works. And in theory, if we don't move a whole lot, what's that? Invalid radius, because we need to get that from our shape. There we go. And I'm actually surprised by that because I was kind of... I think that's normalized. Why is move a float? What am I doing wrong here? What am I doing wrong? I'm updating something the wrong way around somewhere. I'm scaling up move by move step. Let's go and put that between brackets. And move is a vector. Okay, let's just go and let's get our things to help us out. So this should also be a vector 3. Okay, I'm not using delta. Fine. Okay. Yeah, I think because I didn't put that between brackets. I think that was our reason. So we were getting the wrong value back. There we go. All right. Here we are. Still moving around. It's all good. It's still, and of course I'm too close to my desk. Okay. Hey. Oh yeah, that's because I am really too close to my desk. My collision shape isn't form fitting there, but that is all still working. Okay. So let's see if that solves our problem with our door. All right. Well, I can still do that. That's cool. Yeah, don't go closed. Okay. Yeah, that was indeed our problem. Because when our collision shape is now all the way through the door, it wasn't actually moving. Now, in theory, that should mean that, yeah, once we go around the door, oh, there we go. So, and this is now nicely, there we go, perfect. And that is because now we're actually using how much we've moved. Oh. We've still got that. So, obviously that's something that I need to play around with the amounts as well. Yeah. This is pretty cool. So yeah, I think I really need to tweak with how much force we're applying for both the door and when we are touching it like this. But other than that, in principle, everything works the way that I expect it to work. So that's pretty cool. I can open my door, I can push my door closed, and it reacts. But that's really interesting that, you know, now that we're using a force to push against the door, our hinge works exactly as we want it to work, while our move and slide with inertia is actually pushing our door through its hinge joints. Now, I think we can do a lot better with tweaking the other values on our hinge joint to make it, you know, slow down more, because it feels like a really flimsy, well-oiled door right now. But other than that, mission successful, I would say. In principle, everything works the way that it should be working. It's just tweaking numbers now. Now that was really interesting. I was not expecting move and slide to look at the new location of where the character is going to end up and then do a collision check on that new location and not check in between positions. Now, for large movements, this is going to be a problem, right? Which is probably also one of the reasons why why we might want to look at that max distance. Although I think in this case, yeah, I'm kind of happy with that, because if you really move our arm way too far, at some point we do want it to snap into a new position and not worry about it. But in this case, it really snaps into a new position, so I think that'll be okay. But obviously, you know, if let's say that we move 5 centimeters through the door, and we're checking at a radius of oh no, our radius is 4 centimeters right now, isn't it? 0.002. So yeah, let's say that we've moved, yeah, going all the way through. So in worst case scenario, this is really worst case scenario, we're doing 10 move and collides to move our body. And I think in reality, and I guess that's going to happen when we really move the character with the controller or with teleport. I think we can live with that, to be honest. I think that will be something worth investigating later on and seeing, okay, and I think it's going to be a lot to do with what our max distance is. How far do we check? And how far do we say, okay, if you've moved that much, then you're just going to, you know, move to this new location. Yeah, I think it'll be alright. Because generally speaking, you know, we will move to the new location, and then the next frame we just do 1 or 2 move and slides. It should be fine. So yeah, I think that's that is pretty good. Hey Steph, nice for you to join us, although we are about to round off. So 3D curve stuff. What do you mean 3D curve stuff? Like drawing curves or making things move along a curve? But yeah, no, that was the whole point of today, was trying to get that interaction with the door to feel really smooth. I don't think we're exactly where we want to be, but I think we're now at a point where it is really tweaking numbers. I think all the logic in principle is doing what it should be doing. We are applying the force in the right way on the door, and it is behaving predictable as a result. I think mostly it is now about playing around with the smoothness of things. Maybe play around with the weight of the door to make it look. Right now it feels very plasticky, very light. And it really needs to slow down more. So yeah, might be something with that. I'm not sure. Those are all things I just need to start playing around with and seeing how much effect they have. I think I need to play around with the strength of the forces that we apply, especially around the hand. But yeah, it does really feel much more natural now. So, and the door works behind properly. It doesn't fall back. It doesn't go into this endless feedback loop anymore. So I think that has everything to do with the fact that our center of gravity was in the wrong place. So correcting that, I think, fixed that. Probably need to do some more with the cup, because that one did behave a bit weird. And again, I think actually let's try that. That might actually work properly, because I think the problem that we had was that we had moved our hand so much that we were now inside of the cup, and our physics engine no longer detects it as a collision on the edge, but sees us as just moving the cup. Now, the cap is definitely still not working very well. And the same with this guy. So we get this little bouncy thing, which means that the weight of our coffee machine is... Here So that is that problem that I was talking about, that we are now inside there, and that's why we're shooting it. So that's something that we need to fix too. Our little ball is inside of our handle, and when we let go, we are now giving it too much force. So here you can really see that the force that we're applying is way too big. And again, that was because when I built that logic, I was playing around with the door, and I made the door 10 kilos. While our cup here is way lighter than that. So we're giving it much too much force for the weight of that cup. And I think what we need to do there is probably scale our force a little bit more depending on how weighty our object is. And again, maybe that also means, oh, maybe we can actually make that a lot lower. Let's go and have a look and see if we can just, whoops, make our, did I make that a setting? I did. So I'm just going to make that impulse factor back to 1. Because there we apply our force to our actual movement. Let's see how much difference that makes. So in this case, when I move the door, I'm still moving the door quite fine. So I'm happy with the fact that our force is a lot less. The door still moves fine. How about a cup? Cup, how are you going if I do this? Okay, the cup still gets quite a bit of force. And I'm too close to my thing again. Okay, let's... just want to move the cup somewhere a little closer to us so I can actually see what it's doing. So yeah, I am definitely... yeah, we're definitely moving the cup a little bit too much. Oh, that's just worth tweaking some more and having a bit of a better look at, okay? What is the force that we're going to apply to our object? Again, you know, we're now using a sphere to push against our cup. Not a flat shape of a hand. So that is something that that might improve things as well. I'm not sure. That's worth playing around with. Yeah, I think for now this will do. I think that's good progress. Oh, cool. Yeah, the CSG polygon path follower, I had some fun with improving that. So it's good to see someone else working on that as well, because I think that can definitely have a lot of improvement. So yeah, cool. Still have to get back to that at some point in time and use that for my my racing track stuff at some point. Anyway, yeah, the rest I will play around with myself and tweak it some more and play around with it some more. But I think we've got all the ingredients, and I hope you guys enjoyed watching me experiment with this and try and figure this out and try and deal with the problems that I have. That is much more to be done here. I think this gives me more than enough material to make the next part of the tutorial in this series. Now, obviously, like I said, one of the things that I want to do is drawers, pulling out drawers and stuff like that, opening drawers, closing drawers, which is going to be similar to this, but it'll probably be a follow-up. So we're going to deal and finish with the doors first. Probably implement another door in this logic. I'm actually thinking about adding a door between the living room and the hallway, because one of the things that is still missing here is that we should have a locked and unlocked state of a door. So when we look at something like this, it's when the door is closed, we should really only be able to open it by grabbing the handle, and we might even want to make it possible to move the handle to unlock it. Although that might not be the right away the thing that we should be doing for the next tutorial. We might do that tutorial after that. But I do want to have that state where when it's closed, we can't actually push it open. So you have to use the handle to open the door, and when the door is no longer in its closed state, that's where you can push it back and forward to open it and close it. And again, once we close it fully, we should be at a place where we say, okay, now it's closed fully. We turn it back to locked, and that would be a switch between the door being a rigid body and the door being a static body. So that'll be fun to implement, and I think that's going to probably be the topic of the tutorial video, because obviously we've already built everything else, so we'll build that as part of the tutorial. But I think we've got all the ingredients here. It is working the way that I want it to work. We can push the door open, we can push the door closed, we can interact with the handle. We need to tweak with the numbers so much to make it not vibrate and stuff like that. But I'm not too worried about that. I think that'll be fine. I don't think that'll be too hard to build properly. So, yeah, thank you all for joining. I hope you guys enjoyed this. I do plan to do these more. Again, this is not going to be a fixed stream. My fixed stream will remain Friday, working on the space game. But a stream like this, I'm planning to do more regularly as a preparation to videos coming out. Again, tutorials, they do take a lot more time to build. I probably still have a couple of weeks in front of me before I actually turn this information into a tutorial video. But at the same time, this is nice content for you guys to follow along. People get a sneak peek of what we're doing, get some insight in how we get to the result that we got to. And yeah, I hope it was very informational for everybody. So again, thank you for watching. Have a great day, night, whatever time it is over at where you guys are, and see you next time.